Now, let's get into the really exciting part, regulation. So, regulation is almost part of this training that I don't necessarily, well, I've got an opinion on it, but it's not something that we've kind of documented. Regulation is really around the government requirements that are connected to you as installers or contractors installing irrigation. So it may or may not be something that you're conscious of, but there are licensing requirements for the installation of irrigation in South Australia, and it's something that is probably under-regulated and under-policed, but they do exist. And I would say if we had a safe space for everyone to talk, most of you probably would tell me you don't have a licence. I'd be surprised if there's more than 5 or 10 people in here that have a cold water plumbing licence, but most of you are probably interacting with irrigation at a scale that's above 25 mil. So you'll see in the table there on page 11, I've basically built out some information around where licensing is managed. So licensing for irrigation and everything else, landscaping, construction, is all managed by Consumer and Business Services. Now, I spoke to the Consumer and Business Services head of licensing in the preparation of this training because while I was putting together this document, there was some things that didn't add up. And the reality is irrigation kind of sits in this space of a peripheral trade. Landscaping is already somewhat of a peripheral trade that doesn't get the respect that it deserves comparative to, the sexy trades like plumbing, electrical, and carpentry. But irrigation is almost like a peripheral to landscaping, and so it quite regularly gets left out. But the reality is, in South Australia, you are required to have a licence to install irrigation pipes above 25 mil. So you can do any irrigation up to and including 25 mil. After that, which is pretty much everything that you guys probably touch. So, if you're doing a sprinkler system with 63 mil mainline, there's people here that are probably installing 110 and 180. If you don't have a licence, you're not compliant with the state legislation, but you're unlikely to get in trouble for it. And that's not financial advice. I just know that of all the fires that are burning, the lack of licensing in irrigation is quite a small fire that they're not deeply concerned about, but they're now very aware of, thanks to my phone call, so sorry about that. But it's something that they want industry engagement on. The reason there is no licensing, or there's a limited number of licenses, is there's no direct training pathway from the education to the licence. And this is something that we've been dealing with the landscape industry. I also serve on the board for the Master Landscapers of South Australia, and there is, or was, no direct pathway from an apprenticeship into a licence. Now that's something we're working on. I don't know that, that could be done pretty quickly, to be honest. Might be done in the next 6 months, but the irrigation industry has the same problem, and obviously if the body that represents you as irrigators in Australia aren't actively engaging with government on this, then it's not likely to change. So I know that probably, me dobbing us in is probably not ideal when you think about it at a ground level, but the reality is it is actually a really good idea. The more of you that hold that licence and the more serious they take it, the stronger your value, or the higher your value is as irrigators. And if they start policing it and you don't have the licence, then the reality is less licensed irrigators, lots of licensed irrigation work, more money. So, that's one way to look at it. It's also probably important that we're not causing public harm and damage to public property by installing things incorrectly. So I put this in there at the start of the training with the intention of you understanding that there are regulations that you should adhere to. It's up to you what you do. I'm not gonna, I've just dobbed you in, but I'm not gonna dob you in. I'm not gonna, judge you for doing it. I have installed irrigation. Like I said, I did a couple of days of irrigation back in the day. I wasn't licensed, but I encourage you to, if those education pathways become available, it won't surprise me if there's I won't call it an RPL because it's not the appropriate term, but there might be a trade recognition certificate that might become available. I don't know, this is just me theorising because this is what's happening in the landscape industry. And then it might give you an opportunity, if you've been installing irrigation, you might go do a 2-hour interview and and show your skills, and then you might be eligible for that license. But keep your eye out for that. It's not something I have any control over, but it's something that I expect will pop up. Obviously, if you are installing backflow prevention devices, which we'll talk about further into the education, you need to be a licensed backflow installer. You can't get your you can't just get a cold water plumbing license and do backflow. So you'll still need to be using a licensed plumber to do your backflow installations, and then hopefully as this license fleshes out, then you should be able to then do everything after that. There's another note in there about electrical. Obviously, as people that deal with water, it's highly advisable that we don't deal with power as well. Usually they don't work well together, but if you are getting an irrigation controller hardwired, you need to have a licensed electrician. And both the plumbing and electrical work that I mentioned before generally will come with certificates of compliance. So I encourage you to put them in the right place and make sure that you stay up to date with the testing of your backflows. The next part around that is workplace safety. I am definitely not the poster boy for workplace safety. We've grown Waterpro on a shoestring budget for a long period of time, and generally when you do things like that, regulation and training and safety kind of falls to the wayside. We're catching up on that now, but I also acknowledge that selling sprinklers behind an irrigation counter has a much lower risk of harm than the work that you guys are doing out in the field. So I encourage you to make sure, and most of the people in this room have no choice but to be as safe as possible because you've got that many eyes on you and you're working for departments that are very strict around it. I can't speak to JSAs and SWIMs like probably everyone in the room can. It's important that it's in this document so that you've got a reference point to go back to, that you want to be conscious around safety and be wearing the right gear. Dial before you dig is the next section there. There's a lot. It's funny, when I was working behind the counter at Kent Town, we'd have a lot of cables getting broken in the Adelaide City Council parklands because of contract work that was being done. And a lot of that can be overcome by dial before you dig. I know this is probably common sense, but I need to say it because there could be one person in the room that's not aware of it, but there is a service that will come out. It's now called Just Before You Dig because no one dials, they just go on the website. They will get you plans, but it's also strongly advised that if you're doing a large commercial project and you're in a public space, which most of you are, obviously not the new development kind of work, but you really want to make sure that you've had a service locator come out and identify potential problems, gas mains, NBN cables that cost, I don't know, hundreds of thousands of dollars if you ask the council, but if you can identify those potential risks before you get to the point where you start damaging things, it's going to save you a lot of time and money. Now, before I was talking to Caesar, just at the start of, before we started, he was asking me about backflow. He's like, are you going to talk about backflow? Are you going to talk about backflow? I'm like, yes, I'm going to talk about backflow. Backflow prevention is something that's being asked about a lot at the moment in our world, for a few reasons. Obviously, we have an irrigation department. We have an irrigation design department that is working on a bunch of different projects, new developments, local government upgrades, that kind of thing. And we would send a plan off to get checked by the OTR, which is the Office of the Technical Regulator, and then they'd come back and say, you need another backflow, or that's not the right backflow. So backflow prevention devices are, as you'll see in this book, designed to protect the water supply from potential harm. And what can happen is if a pipe breaks or there's a back pressure of some sort down the pipe, you can have a suction that can attract or that can drag in things that are outside of the pipe. So if the pipe's in the ground, it could be drawing in dirt, which might be contaminated with herbicides, or if you've got a fertiliser injection system, it might start dragging in fertiliser and chemicals. And if you've got an acid doser, like a lot of golf courses do, they actually add hydrochloric acid to their water, there's a potential that you start dragging hydrochloric acid back into the drinking water supply. Backflow prevention devices in a residential situation are very under-installed. And for the cost of them, it bothers me a lot that it happens, and I don't know how bad it is now. I haven't worked behind a counter for a while. I guess you two do. When you're selling residential irrigation systems and you're designing backflow, are people still hesitant to buy that because it's an extra 30 or 40 bucks, or is it kind of, yeah. So the problem is that, especially residentially, they don't put that backflow in. The highest risk they've got is contaminating their own house. Like, it's not like by not putting it in, it's not your problem. But commercially, there's a lot of risk, but there's also regulations, and that is something that there will be eyes on. So it's important that you understand your backflow requirements. It's important that you have a licensed plumber install your backflow devices, and it's important that you're across the backflow requirements. Now, they're quite complicated. It's, I guess, at the start, but once you understand it, it's not so bad. So there's a table there on page 13, or the table starts on page 13, and it really shows you the 3 hazard levels of backflow prevention device. So low hazard is that little brass cylinder on the bottom right-hand side of page 13. That is 2 spring-loaded pieces of plastic that let water go one way. That's it. They're designed to stop low hazard, so things that are probably not going to cause harm. So, you know, if that situation in someone's backyard where they put in an irrigation system had a backflow prevention issue, they're probably going to just potentially draw in, I don't know, some dirt or potentially some residual fertilizer that's attached to the leaf of it. Like, it's very low risk. But once we start moving up to local government and public space, you'll see there's a medium hazard device there, which is called a double check. Now, a double check is a testable device, and once that gets installed, it's a requirement by SA Water that licensed plumbers go test them every 2 years, I think, and they have certificates of compliance. And so if you see on the top of the photo there, they've got these little nipples, effectively, they're threads. They'll hook up a pressure testing device to that and test that the backflow prevention device is still working. You'll see that is inside the ground. That backflow prevention device doesn't have anything come out of it. That's relevant because the next one does. So a medium hazard situation obviously is where contamination could cause illness but not cause death. So the reality is, for most public spaces, if there's no recycled water or non-drinking water involved and it's just drinking water and the standard applications of fertilizer and that kind of thing, double checks are generally fine. All of this information is available online, so you can get the documents from SA Water around what they consider harmful and what they consider high risk. There's a document with like all these different scenarios where there's an oval and recycled water, or non-drinking water and drinking water, or there's a building, and then so it shows you all of the possible computations. The OTR guidelines. I've actually got the file on my computer, and I guess if it was of interest, we could email all of my reference documents to all of you. Did they ask for your email when you registered and signed? Or just the master email? We can still send it. So what I might do is actually send out all of the documents that I referenced today, just so you've got them. Obviously, I am not a registered training organisation. In fact, I didn't even finish high school. And so the stuff that I'm telling you today is my opinion, and the information that we talk about is referenced from government websites, conversations with local government. So I'll send them to you so you've got them, and then it's up to you how you engage with that, and you can decide what your thoughts are. But we're seeing now a request to install 2 dual checks on almost any system. And so for the older heads in the room that have been in irrigation for a while, you might remember we used to install 2 RPZs residentially when we installed drip tube, because we were pumping Treflan through drip tube. So back in 2006, 7 and 8, water restrictions meant that we weren't able to water with sprinklers. And so we were putting subsurface drip irrigation in residentially, but then we were introducing a chemical to that to stop the roots from growing into the drip tube. The SA Water required an RPZ, which is the next backflow prevention device that I'm going to talk about, at the valves and at the boundary. Now, we're starting to see SA Water ask for this in commercial situations where there'll be a double check valve at the boundary of the oval or the public space, and then they'll want another one protecting the public space. So if you could imagine, well, I bought the paper, I might as well use it, eh? So if you could imagine you've got you've got your mains water, and can you see this? Yep. So you've got the mains water there. You'll have a backflow there, and then everything between those is toilets and buildings, right? So I told you I didn't finish school. Missing letters. And then everything after that, then there'll be another one. Sorry, that's wrong. There'll be another one here. All these toilets and buildings go in here. That protects all of the activities on the site from contaminating the rest of the world. And then the pipes that come out here go to the toilets and water fountains and that kind of thing. Then there's another double check here, and then the irrigation system goes off. That double check protects damage to the site from the system, and then that double check prevents the rest of the world from the site and the system effectively. My argument is if that one doesn't work, why do we need two, right? Like if why not have 15? But SA Water don't see it through the same lens, and that's a horrible picture. I'm sorry about that. They will get better throughout the day. They are all asking for that even if there's nothing on site. So the situation here, we have toilets and buildings on site. We've had recent interactions with a local government body that have asked us to put 2 in because their interpretation or understanding from SA Water is that they need them there anyway, regardless of what's here. So they need to go in. So that's a bit of a moving target. We're working on that. It kind of came up this week because I was doing this, but also because we've got some irrigation designs for a new council, or a council that's new to us from a design standpoint. So they requested that. This is a bit further down the track, but the risk or the concern to us with this is each one of these devices takes 50 kPa or thereabouts of pressure from a system. And the pressure that's available from a local government standpoint for irrigation systems getting worse and worse and worse. Obviously, we're urban sprawls, putting more properties, more demand on the network. It's an aging network of pipes that are delivering water to everyone. So if the pipes have the pressure reduced, and I theorise this, I don't know if there's any truth behind it, but if I'm United Water, or what are they called now, All Water, and I have a network of pipes that keep breaking and I've got a fixed price to manage it, I just turn the pressure down, the pipes don't break, make lots of money. I don't know if that's true. I'm a very cynical human being, so it could just be me being an asshole, but it's getting harder and harder to get the pressures that we require to pop sprinklers up, and we'll talk about this further down. So every time we add a double check valve, we lose pressure. In saying that, I acknowledge we need to protect the drinking water. There'd be nothing worse than a human going and drinking from a drink fountain and it's contaminated with a herbicide or something like that. So that's what that's there for. The last one is high hazard. So that's an RPZ. I talked about them before with the backflow prevention device for Treflan or chemical introduction. So if you were, I know the Barossa, is anyone here from the Barossa? I mean, I know you're from, where do you go? You're from the Barossa, but anyone from Barossa Council? So they've obviously just done that oval at Lindock, and that's got a fertiliser injection system connected to it. So they'll need to have an RPZ installed to protect there from any risk of wetting agents or fertiliser from getting backflowed or backdrawn into the mains. So that's backflow. I probably went on that for a bit long, but it's important that you're across it. It's really important that they're going in. It's there to protect, I guess, the people that you guys serve, I guess. So I think that's it from a backflow standpoint. It's unsafety, the undial before you dig. I'm not a big PowerPoint user. Is that obvious? All right. There's page 15 talks about some recycled water requirements. In South Australia, this is really important for you guys to understand, but in South Australia, recycled water and drinking water must never connect. And so backflow comes into play here. And this is what Caesar was talking about before. Recycled water or non-drinking water is, in a lot of cases, probably harmless, but it needs to be treated as harmful. And so if you have a site where you've got 2 water sources, one's coming from recycled and one's coming from mains, there needs to be an RPZ to protect the mains. They consider that recycled water high enough risk that you need an RPZ. It's also important to note that all of the recycled water network needs to be lilac. and to the point where they actually have the lilac colour that they want. So it can't just be a dark purple or a really faded purple. It has to meet certain colour standards. And in South Australia, it's not acceptable for blue line, which you guys might be familiar with, to be used as a lilac line. So you can't go buy black metric pipe or mains pressure pipe with purple lines or lilac lines on them. All the water that's travelling through the network in recycled water situations must be coax, which is a co-extruded pipe. So you'll find that the inside of it's black, and then there's a complete lilac sheath. So if you look at the bottom of page 15, that's coax. I think I actually talk about this further, and there's 2 pictures of the striped pipe and the coax pipe. But I just think that all commercial irrigation systems should just be lilac, and it would just save a lot of trouble. But I haven't really gone to lobby that, and I have enough fights going all the time that I don't really want to go start another one. But I figure you probably shouldn't be wrapping your mouth around a sprinkler or a piece of drip tube ever. So why not just make them all purple and just assume that the water that's coming out of it's not something you should be drinking. So the last section of regulation is business protection. So local government, your business protection is probably handled in a department that's different to the one that you work in. And then commercial landscape, your regulation would be handled probably in a department that you're not in as well. But the reality is to be doing the jobs, well, from a local government standpoint, it's probably important for you to understand that it's best practice or a good idea that the contractors that are working on your sites have appropriate levels of insurance, public liability being one of them. Most of the tenders that you guys put out have a minimum 20 million public liability, and it might have even gone up, so I haven't looked at a tender for a long time. Professional indemnity is a really important one. That team over there is covered by professional indemnity. If you're doing irrigation designs, we recommend that. Return to work's in there, which some of you might know as work cover. Obviously that's mandatory. And then asset protection, insure your cars. I know that this is all common sense stuff, and today there's probably going to be a lot of that. I just want to make sure that it's in the document so that you've got this kind of umbrella understanding of everything that I think matters in the industry. And I guess that will hopefully serve you from a development standpoint. The last point there being documentation and record keeping. This is an interesting one. There's only really a few mandatory things that you need to be keeping records on, which are things like your certificates of compliance around electrical work and plumbing work. But I also think it's really important if you, in a world where it's not my fault, that you cover your ass. And I hate that it's a thing, but it's a thing. And so if I was installing irrigation, I would be taking photos of almost everything. I'd be documenting everything. I'd be videotaping pressure versus flow tests. Like, all of that matters because stuff happens. I won't say that, well, no, that's all right, it's just Irvo. Matt was telling me a story, I don't think it was him that was doing it, but about when there used to be main lines basically put under roads in subdivisions when he was younger. The kids would drop tennis balls down them, like, to cause whatever. Obviously, if you can go to the extreme of covering those pipes with something or to protect them and then take a photo, and then if they've been removed, you can say, well, we did this. It's not a great example, but keeping records around pressure versus flow is a great example. You could put a new irrigation system in, and we'll talk about pressure versus flow later, but you could put a new irrigation system in and it's working completely fine, and then 45 days later they're not popping up, and then all of a sudden someone from this side of the room is calling someone from this side of the room to say, hey, you're not very good at installing irrigation, it's shit, the sprinklers aren't popping up, and then you can go out and actually prove that it was, and something's changed. So in a world where everyone's got a camera and a computer in their pocket, I really strongly encourage you to take as much of that as you can. And I mean, I don't know, you might have systems in place, especially the commercial guys, to track this anyway, be it whatever the software is, if you're using Slack or if you're using Asana or Teams or whatever to try and track all that information. The time that it takes to do that will more than cover the costs of trying to prove that you did something right. That's probably it. The equipment warranties is a funny one. We used to have to hand these documents in when we finished a commercial project with all of the warranty documentation and all of the brochures. The reality is it's all available on the internet now, so I don't know how much they're chasing that, but that is it for regulation. Regulation wasn't supposed to take that long. Sorry about that. You said this would happen. I was talking to Mudge and I was like, I think I'm going to run out of time, which is all good for our friend over here that wants to go home at 2 o'clock. But I was like, I think we're going to run out of time, but I think you guys might just have a 20-minute lunch break now, so we'll be all right. So, specification is the next pillar. I need to work out what I'm delivering, at what time I'm going to finish each thing. Just give me a sec. I'm just going to look at this. So specification is something that is probably commonly accepted as a commercial thing. Yeah, the start of design. Okay, we need to move. So specification is something that's generally understood as a commercial thing, but the reality is everyone has some form of specification. It just might not be documented. So if you're a residential irrigation installer or a residential landscaper, you might have a specification that says we only install this brand of controller and these valves, and we always make our manifolds out of PVC and whatever it might be. We only use commercial valve boxes. That's a very simple specification. And then you can go right out to a 45 page document that the local government use for specifications, and obviously developers do as well, and the Department of Transport. The specification exists to protect everyone. Actually, I'll go back. The specification is a document that describes how and what and where an irrigation system needs to be installed. So it talks to you about the products that need to be used. It talks to you about the procedures that should be used. It talks to you about who should be doing it. So do they need to be licensed or do they need to have an appropriate level of education? It talks to you about who to contact when something goes wrong. And it talks about when to stop to get approval to continue. And that last one's really important. We don't see hold points being managed very well, but I'll talk about that further into the specification. So the image that I have on my screen is stolen from the City of Adelaide. Is anyone here from the City of Adelaide? They're not here? That's right. We didn't invite them. We sold out, bro. So I've used the City of Adelaide's documentation because it's publicly available and I've figured that I'm allowed to. I probably didn't say this at the start, but I stole a lot of information to put in here. So I've stolen pictures from other websites. So if you see something that is yours, I'm sorry. We probably haven't made any money, so I can't pay your royalties, but Adelaide City Council's got a publicly available spec, and it's got a publicly available suite of standards or drawings on how to install things. There are other people in the room that would have that. I know we used to reference Playford City Council's spec a lot because it was so robust. The document that has the words is as important as the document that has the pictures, which are gone. Sorry. The pictures really detail how things should look, and then obviously the document that has the words detail how things should be installed. And that'll talk about standards that need to be met. That'll talk about how a controller should be installed, what the controller should be. It'll talk about depth that solenoid valves should be installed. So this is a great example of that. It talks about like even this one, it's got a 90-degree bend going into the solenoid valves instead of, say, a 45. We have these specifications in place so that there's less chances of something going wrong. And as you'll see, I mean, there's a lot of, you could probably read this and get the gist of what I'm talking about, but I'll go through it. The spec's not just there to protect the client. So if this specification in this case is written by Adelaide City Council, it's not this thing that's designed to, put the contractor on their knees and the council get their way. It actually protects contractors just as much. And the reason that is because when you meet a specification, there's a standard that needs to be met. So when there's a tender process, it's a competitive tender process, and you're not having these commercial contractors losing work because they've done a certain standard, which is their standard, and then they're losing to a bid that's shit. And so it can be easy to be critical of a specification from one side or the other, but the reality is it protects everyone. It ensures that there's a professional standard that's being met, so obviously that's competitive, but that professional standard also means that if you're working for local government, that the residents that you represent their dollars are being spent responsibly and that you're buying a piece of infrastructure that's going to last 15 or 20 years if you listen to my maintenance bit. So the specification is a document that lays out, like I said before, what products go in the ground, how they're installed, when hold points need to be checked, and then who to contact when something goes wrong. Our design department also use those specifications, and we'll talk about this a bit later, but we've got a design checklist which you won't be able to see because it's tiny. That's the biggest piece of paper we had. When they're designing a system without a specification, we're just kind of throwing things on a page, and it might be hydraulically correct and it might have a suitable precipitation rate, but then, you know, yesterday we had, I don't know what it was, that's not the right controller or whatever it is. Now, without a clearly written specification, we can't do the design well. So it all connects. And my desire today was to be able to create you this, almost this loop of how it all connects together. How regulation is important, but then how a specification sets the foundation for the design, and then the design, is a map that is really clear to understand for the installation, and then the installation goes in as per the spec. The job gets handed over well, it's auditable, so the audit comes into play, and then obviously you maintain it, and then there's this, it's kind of this cycle of irrigation. So, as I mentioned, without the quality spec, it's really hard for us to create a quality design, and without a quality design, it's less likely that you're going to put in a quality system. Now, one of the things that I mentioned a little bit earlier was hold points. Now, that's, I guess, the when to stop. Adelaide City Council's spec, which is publicly available on their website, you can search it up now, has, I think, a decent level of hold points. And when I say a hold point, it's a point where a contractor would be called by a local government, or potentially it could be a resident, to say, I want you to come and inspect our work at this stage. I think I talk about hold points a bit further, so I won't go on too much about it, but if you want to put in your spec what matters to you. And I think, I had a section here called Start with the End in Mind. The spec's really something that, I mean, we write specs for people. I think we got engaged to do one yesterday, but you could do this yourself. And ultimately, you could probably use AI and have one knocked up in 2 minutes. But the idea is that you determine what's important to you and then work backwards. And this is how we do most things in business. We understand what the end goal is that we want, and then we work backwards. Now, from a specification standpoint, for some of the regional areas might find that budget is more of a concern than precipitation, or budget's more of a concern than central control. And so their specification might call for non-head-to-head coverage, or a lower cost sprinkler, or a hardware shop available sprinkler, or a controller that's not centralised, or things that cost less, because that's what matters. And then you might find that, you know, areas like Adelaide City Council, I keep pointing back up there. Sorry, Adelaide City Council, which is a highly frequented lens on the lawn all the time kind of council, has to have a really high quality spec because there's so many people watching and there's so many people, you know, making phone calls to the mayor and to the councillors about their lawn not looking good. So start with the end in mind, build out a specification. Anything is better than nothing, but obviously if you care about your irrigation infrastructure and it's something that you're going to focus on, and you want to kind of close any open loops and you don't have a specification, I strongly suggest you get one. If you, as a local government, were looking to write your own spec and wanted us to peer review it, we can do that. That can be a more inexpensive way of doing it. It's also important not to leave this out. The written word is a lot more misinterpretable than something like this. And if you say that's how it should be installed and it's not installed like that, fix it, it's pretty clear. So the next section that I've got around the specification is an interesting one. It's around material selection. And obviously we are an irrigation supplier. And so we are, I guess we have an opinion about this, and that's what, I guess I'm here, I can give you my opinion, but this is on page 19. Material selection is really important, and because we are a retail and commercial irrigation supplier that also has an irrigation design department, we have this beautiful ability to identify when things are going to fall down before they get there. And we've got a job at the moment that we're supplying that we didn't design and we didn't specify. And it's got a sprinkler in it that's not available in the country. And so in a normal world, if we order that and it comes on a boat, we're probably 12 weeks. Now, it also happens this job needs to be finished in, 30 days. I don't know the exact details, but there's government eyes on the job. It needs to go in. So it creates complications. If we were involved at a specification level with that council, then we probably would have highlighted that. And then, it also, on the other side of it, the sprinklers cost heaps of money and better for us, great. But the problem is, if you can't get the sprinklers, it doesn't matter, right? It doesn't matter how amazing they are and how high they pop and what their pressure regulation is and how good their DU is if you can't get them. And so when you're specifying an irrigation system, I strongly suggest you be considerate to what's available and what's readily available, because there's obviously things that get brought into the country. That's cool. It doesn't mean that they're available in South Australia, and then it doesn't necessarily mean that they're available at a retail level in one of our stores or whoever you choose to buy irrigation from. You can find that out by talking to us, and you can find that out by talking to most irrigation businesses and get an understanding of what's available. The design firms that don't necessarily have as much contact with the people on the ground, from time to time will put a product in that doesn't exist in Australia, and it could be because they don't import them. So Rainbird, there's been pressure regulators or pressure regulating filters that they just don't import. There's been screens they don't import. I think we had that with Playford Council. They wanted 120 mesh and they only did a 200 mesh. So it's important to be across that, because you might not be able to get it, but if you can get it, it might cost you twice what you should be paying, and then all of a sudden you're not getting as much bang for your buck with your residents' money. So think about that. I've got their brand consistency. This doesn't matter as much, but I think it's important to choose, if you can, a brand that is going to still be here in 20 years, but also that's not just going to be here in spirit. You want a brand that's going to have people on the ground that care about, and this is hard to forecast, but you can see into the future somewhat, because history tends to repeat itself. But there are people possibly in this room that are changing brands currently because the wrong brand may have been chosen at some point. Maybe it was the right brand at the time, but choosing international manufacturers with 40 years of history, with warehouses across the world, with staff on the ground in Australia that sell products that have decades of history, makes sense to me. And you might want to mix and match a little bit. I know that I mentioned the Barossa before. Their spec's quite diverse. They use multiple brands. It's fine. I think the advantage of choosing a brand and having a holistic system with one brand puts you in a different level with that company. And I think you might find that when you need help, that you might be more likely to get help quicker. In saying that, as I'm saying it, I'm thinking maybe if you keep it spread, then they're going to have to work harder for you. But just be conscious around brand and choose wisely, because otherwise you might find yourself changing out 140 controllers because they're not supported anymore, or they don't centralise, or whatever it might be. One of the other things that's important around choosing your products and choosing your brands and having singularity of range is for the people that are out there doing the work. Now, I'm guessing a lot of people in this room are actually getting their hands dirty, and they're out there doing work and putting in new irrigation or fixing existing systems. If you have 5 different solenoid valves across a local government, then you have 5 different coils potentially and 5 different diaphragms that you need to carry as spare parts in your trucks. It's also 5 different solenoid valves that you need to learn how to deal with. And then it's also 5, manufacturers that may or may not exist. So if you can choose to have a single standard, and most people do this well, then the amount of spare parts that you're going to need to hold as a contract or a repairer is going to be reduced. So, hold points. I mentioned they were coming up a bit later. So there's a few examples of hold points there. Sorry, back to me not using this properly. Yep. Sorry, Celeste. Celeste did an amazing job building out this, and I'm ignoring it. All right, hold points. So professional hold points is a good opportunity for a the person that's paying the bill to check with the person that's installing the system that they're doing things as expected. And that doesn't necessarily mean that the person installing the system is not doing a good job. It might just be that they've got a certain way they do things and it's not in line with how the person that's paying the bill wants them done. Now, Adelaide City Council, we referenced before, from memory, don't have concrete slabs under their valve boxes. They don't like them, they don't want the chance of water pooling, so they use an aggregate. You might have installed a bunch of systems throughout your career that always have slabs under the valve box. The advantage of having these hold points is that someone from the council or someone from the developer, in some of the people's cases in this room, will come out and they'll inspect that work. So I've got here first valve box, I've got here pressure versus flow. They'll come out and they'll check and they'll go, okay, the valve box has been installed appropriately, it's level, it's at the right height. Obviously some valve boxes get installed under the turf, the finished turf. There's a metal plate in it if that's what's required. The valve's pointing the right way. The wire joiners have been done appropriately. The ball valve handle's not touching the valve box. All the stuff that matters from the picture that we can't go back to now, but you'll remember it, it's in your book. Usually if they see that once, they'll leave you alone, and the contractors in the room can probably confirm if that's the case, but as long as you're on track with how it's meant to be going, you'll probably get left alone. It's really important that they see that first and then off they go. Same with mainline depths, sand in trenches, all that matters. The top one here, pressure versus flow test prior to starting, is something that gets left out all the time, and I can't harp on enough about how important it is. Water pressure and flow versus pressure, which we'll talk about further in our training, is the thing that matters. Everything we talk about is connected to that. So the specification matters because of what sprinklers are going in and the pressure they operate at and the flow they operate at. These guys design irrigation systems based on the amount of pressure and flow that we've had reported to us. Now, we had a situation last week where a contractor started on site and I said, have you done a pressure versus flow test? And they said, there's no water meter. We can't. And he goes, what do you think we should do? I'm like, you need to email the client and let them know that you haven't done one and that you are not taking responsibility if it doesn't work, because there's an assumed flow. And once we talk about precipitation and flow further in today, you'll understand what I mean. But you can put in a whole system, a whole oval or a whole subdivision, a whole streetscape, and turn it on and the sprinklers don't pop up because you didn't do a pressure versus flow test at the start of the job. And if you had discovered that you were 20 or 40 or 50 kPa short because someone put in an additional dual check or the conduit under the road, I mean, that's different. But if you did a pressure versus flow test at the start of the job and it doesn't match what's on the plan, stop and go back to the principal and say, how would you like us to proceed? Because it's ultimately going to be work out why there's no pressure and flow, and it could be that a pipe's been crushed or that the ball valve wasn't open properly or the ball didn't move in the handle or whatever it might be. But it might also mean that the design needs to be changed, so the team get notification they need to split the system in half, so double the valves, half the amount of sprinklers per valve. Or in some cases, Charles Sturt's a great example, there just isn't going to be enough pressure. Onkapring is the same. Some of their sites have just got 200 kPa and it's just not there. They've got great flow, no pressure. What do? We're going to have to install a tank and a pump and we're going to have to boost that pressure. So please, please, please make sure that you've got hold points in your specs if you don't have them in your spec. And if you are contracting, make sure you check that pressure versus flow. I've got a video on that, which I will show you if we've got time. I'm conscious of time. So pressure versus flow tests are quite simple to do. The video only goes for 3 minutes, but I'll squeeze that in at some point. If you don't know what that is, it's like I said, we've got the video. If you don't have the tool to do that, we have a bunch. I don't even think, do we lend them? Do we lend them out? We just charge a deposit? Yeah, so we'll lend that to you for free. So it's so important to do. I'd suggest if you are irrigating on the regular that you'd have one available. I think some of the guys here have probably got them in their utes. It's really, really important. So that's the hold points side of things. If you are, as I mentioned before, doing that pressure versus flow test, it's really important that you document it somehow. I would videotape it and then just store that somewhere and say, well, this is what we had, because if something happens later on, then you've got that evidence. There's a photo of a pressure test there. Oh, that's the last one. Yeah, okay, cool. So that's something else that's probably not being done a lot. You'll see on page 21, there's a pressurization device. I don't know what the right term for that is. I would strongly suggest that if you are the client, that you're getting your main lines tested, where they basically pump the main line up to a certain pressure. It's usually 1.5 times the operating pressure, and then hold that pressure for 15 minutes. It helps you identify if there's any leaks. I think as a contractor, it's probably a good thing to do regardless of if the client asks you to. And then you can document that your pressure test was good. You can videotape that as well. And then obviously if there's vandalism or damage that occurs later in the system, you can say, well, it wasn't us. When we left the site, this was how it was. Because the reality is a lot of what's being done, especially as we move into the north and the south, and I guess up into the hills, we're in subdivisions where there's a lot of infrastructure getting installed and there's no one there. And so the chances of theft and damage and vandalism occurring is higher because, there's no one to catch them out. So, all right, the hardware. We've got half an hour till morning tea, so I'm gonna move through hardware fast-ish because I want to start the first half of design before lunch, I think. I'm lost. Anyway, hardware. This is really almost probably, somewhat of an insulting section for the people sitting in the room. Most of you probably understand the hardware, but I'm going to talk through it as if you don't, because there could be people in the room that have come here with zero knowledge of irrigation, and I just want to make sure that we cover it off. So the irrigation is, I tried to come up with an analogy that made sense, and I couldn't, because my whole life's analogies, because I'm a salesperson before I'm anything else. But I tried to say the controller is the brain, and then the cable is the nerves, and then the pipe is the veins. And I'm like, well, then what's a sprinkler? And it kind of got really weird. So I can't use an analogy for this, but that kind of probably gave you a bit of a picture. And so irrigation is a really, really simple thing, and it gets made complicated by advancements in irrigation control or developments in sprinkler nozzles. You guys would have seen the MP rotators. That's different. But ultimately, we have a controller, which is the brain, talking to the valves through the cable. And then the valves open because they've got water coming into the back of them. And then water goes through the valves, out through more pipe, and it gets delivered via a sprinkler or drip tube or a dripper. So something delivers the water, and that's it. It's really, really simple. And the beauty of that is when something goes wrong, and we can talk about this further, it's kind of easy to diagnose what went wrong because there's not a lot that can go wrong. We're not dealing with a human body, we're dealing with an irrigation system. So controllers are available predominantly, and there's a lot of advancements in controllers, so I might miss something, but ultimately, you've got traditionally wired controllers, which are mains power, plug into wall, run cables out. Controller sends a signal via the cables to the valve. Valve turns on. If the cable loses the power or gets cut, valve turns off. They, as you'll see in the table there on page 21, traditionally wired controllers are best suited for residential and small commercial systems. The reason that is because every valve needs a common cable to it and an active cable. So if you have 21 valves in a system, you need 22 cables going out. And once that gets to a certain level, the loom of copper that's going out, the nerves, becomes so big that the cost is problematic, the risk of theft is high, and the repair and diagnostics of issues becomes more complicated. So there's not a perfect number. People will come into the store and say, when do I move from a traditionally wired controller to a decoder controller, which I'll talk about in a sec. And it depends on the brand. And it might be 20 valves, it might be 30 valves, but it's around that. It's not 4, and it's not 100. A decoder controller, which is bottom on that spreadsheet, is the next one I want to talk about. A decoder controller is the same mains plug into wall, cable goes to controller, cable goes out to valves, but rather than having a common cable to a valve and an active cable, so you need the number of valves plus 1, there's just 2 cables. And those 2 cables go out to every valve in the whole network, and they get to a device called a decoder, and the decoder receives a signal from the controller. It understands that it's my turn to turn on, and then that sends a signal to the valve. And so the advantage of that is you've only got one lot of cables going out, so the cable cost's reduced compared to looms. The risks or the issues that may arise is that if you cut one cable, everything drops. But it's also, there's a lot of diagnostic tools now in Dakota's world where they have reverse communication. Another issue with Dakota controllers is the potential for lightning damage. So the installation process for a Dakota controller is it's a little bit more complicated. They need to put lightning protection in currently. I think that's a moving target as well. But if you don't put lightning protection in and that system gets struck by lightning, then there's a risk that a lot of the Dakotas will be damaged, and the Dakota's, $80 to $100 depending on where you go, and then obviously all the labour that goes around that. When I say that's a moving target, I'm hearing rumours or chatter about lightning protection-free Dakota systems. And so obviously as technology evolves, and I don't remember the rule, but chips and computers double their power and half their cost every 12 or 24 months. Don't quote me on that. But the reality is, I think Dakota controller systems are going to continue to come down in cost because of the receiver device will become less to make, and the cost of copper is going to keep going up. And so what you might start to find is the number that I said before, that 20 or 30 to move from a traditional controller to a Dakota controller might drop down to 10. And then you might start to see residential Dakota systems becoming quite the norm. Hunter do an easy Dakota, which is kind of residentially designed, that's kind of there. So does anyone have any questions about that? It's probably a lot of information without pictures, but that's the gist of it. And I know most of you deal with this stuff anyway, so I don't want to harp on too much about it. So Dakota controllers as well, you can run the cable a long way. Like a golf course could have a Dakota system and just have 3 cables going off in 3 different directions, and the whole golf course could operate from that. You don't have to go having really, really thick cables. When you I'll talk about a cable. So, and then the last one there is solar and battery controllers. Battery controllers, most of you have probably dealt with, which is the Hunter node or similar. It's a 9-volt battery that actuates the coil, turns on the valve, turns off. You would put these in roundabouts or small parks that don't have power. Obviously, the downside is you need to replace those batteries. Currently, like say the Hunter node as an island is not centralised or central controllable, but we are now able to sell battery-operated solenoid valves that are centralisable. So. And that's an evolving space as well. So if that's something that you're interested in, talk to one of our team. But there is the reality that over the next 5 to 10 years, it won't surprise me if there's no cable and that all valves are run by high-powered batteries that last 5 to 10 years with 4G or 5G SIMs. And those individual units can communicate back to a central control, and then a council or a local government effectively only has one controller or a computer, and that talks to 5,000 battery-operated valves out in the field. And then the only thing that you would need to do is to go out there and change the battery every period. But I don't think we're there yet. So that's controllers. Controllers, obviously, there's a few pictures there on page 22. That might give you a better understanding of what I was talking about with all the cables going out to the valves. That's a wiring diagram. I will draw this later when we're going to do a live irrigation design after lunch, and I'll do a design and talk you through the process. We go through how we plot sprinklers, how we wire up solenoid valves and all that, but that's the gist of it. And then the next picture on page 22 is the Dakota. So you'll see it comes out of that controller on the left of that is actually not a Dakota controller. I'm an idiot. I stole that from the wrong website. But the other one, the picture on the right shows the Dakota and the cables, and you can see how much, how a lot less complicated that can be. So I talked about cable before. Cable is no different to pipe. Well, cable with electricity is no different to pipe with water. So when we're dealing with water, these guys over here, all of them, including the guys that are working on the counter, have to be considerate on how big the pipes are that we're using to transfer water from the solenoid valves out to the sprinklers or the drip tube. And the reason that is because as water moves through pipe, it's got friction on the sides, and if the velocity gets too high, then we've got problems. That's when we get water hammer. But also, if the pipe's too small, we don't get the pressure or the flow at the end of the pipe that we need. Cable's no different. We have voltage drop through those cables. And so when we're sizing a job, if we do have a traditionally wired controller, which I guess it's not as common now, but probably 5 or 7 years ago, we still saw really long runs of cable of 1.5 mil squared with 2.5 mil squared. And you know, we were going sometimes quite high in diameter because the further that run is, the more the voltage drop is, because effectively like water, and I can't explain electricity as well as I can water, if there's not enough voltage at the end where the valve is, the coil won't open. And the recommendation is you don't want to drop more than 2 volts over that run. There is a table there to calculate it. I don't think it's important that you know how to do this. I just think it's important that you understand it so that when you're going out and inspecting a site or managing a site and the wrong cable's been delivered by a supplier or the wrong cable's been installed by a contractor, that you can identify that and say, hang on a sec. Because this is like, and if I was trying to increase profitability on an irrigation job, and no one in this room is in this category because they wouldn't be dealing with us, I would reduce cable sizes and try and sneak that through, and you could pick up a fair bit of money. The problem is, if we're designing it to a certain specification, if you start doing that, the reality is you're not going to get enough electricity at the other end, and then the valves aren't going to open, and replacing that is a big problem. So cable thickness is there. Cable configuration down the bottom. This is another funny one that you might not know, but the cables come in odd numbers. So the multi-core cable that I talked about with a traditional controller comes in 3-core, 5-core, 7-core, 9-core, and 13-core. In Australia, we use black as the common. In the US, they use white. I copped a fair bit on the internet about that one. It's not a standard that I created, and it's not necessarily a standard either. It just has become a thing. I find that if you try and stick to these standards when you're going back to sites to try and diagnose problems, if the black is the common, you know that. I used to work alphabetically through the cable, so like blue, brown, and then so on. So I knew that 1, 2, 3, what order the colours were in it. It started to create efficiencies for me and my team so that we knew what we were doing. And you know, you're like, can you turn valve number 1 on, or can you wire valve number 1? You knew that was blue. So it talks there about the 2.5 mil cable and 1.5 mil cable. We do find commercially now we're running 2.5 mil cable commons a lot. Are we running 2.5 mil cable as a common? Yeah. So we have a 13-core cable and a common, and so that means we can turn on 13 valves with the common. I wouldn't recommend that we are only allowing enough cable for the existing valves. We try to allow spares. There's a bit in there about voltage drop. It's important to know, but it's not important for you to be able to work out. 7.4, wire joint best practices. In decoder systems specifically, but in all wiring systems, we do not want water in our joins. We don't want water in our cables. We don't want water to get down the cables at all. I had landscapers do my backyard, and I think they ran the cable for me. And I was going to do the irrigation myself, and the cable was just sitting in the ground, just with the end cut off. That's not a good idea. And the reality is it's probably not going to cause you many problems, but I went and put a wire joiner over the whole cable to protect the cable. Water will start going down that cable and it will start deteriorating and rusting. If that happens in a decoder system, there's a risk that you don't have the communication and you've got issues, and it's going to be hard to find. So protect your cables and protect your pipes. You want to make sure that even the pipes that you're putting into the ground, if they're sitting in the ground for a period of time, just put some duct tape over the end so that there's not stuff getting in there. Obviously, you can flush your systems once you've installed them, but I guess prevention is better than cure. Unfortunately, as humans, cure seems to be the only thing we chase. But so wire joins are important. Buying the right wire joins. The DBR wires, which are on page 24, the ones that have the red and yellow thing goes into the clear thing, they're rated to like 600 volts. Make sure that you're using the right joins for the size cable that you're using, but also make sure you're using the right joins for the system. So decoders really need to be using them. Now, solenoid valves. They're valves. So we have solenoid valves, which we'll talk about later. They're operated using a 24 volt alternating current, which I'll talk about later, or they've got a battery turning them on. It's interesting to note that we've got master valves in that table. In probably all the systems that you install, there's a master valve. But residentially, it's not really a thing anymore. I mean, are you designing master valves into backyards? No. So I think it's a nice to have. A master valve is a protection valve that goes in front of the bank of valves. Sometimes it'll be a higher pressure rated valve. If I had a shack at the river and wasn't there all the time, I'd probably have a master valve in, especially if I had tank water, just as a secondary protection in case one of the other valves broke. So the master valve, what happens with the master valve? The master valve turns on when water comes through, that it gets to the valve, turns on the active valve, and then they operate. But commercially, they exist a lot. And in a lot of cases, that might be because there's a flow sensor or something after the valve. But residentially, we're not seeing them as often. Pressure reducing valves are there to ensure that the amount of pressure that's being delivered to the water delivery device, so the drip tube or the sprinkler, is the right amount of pressure. Again, I'll talk about that later. I'm trying to not double handle things, but I also want to make sure I don't miss that. Pressure matters a lot. And if you're getting misting from sprinklers or squealing from drip tube and blowouts, it can quite often be from pressure, but also if the sprinklers aren't throwing far enough, if you've ever flown in over ovals anywhere and you see those rings of yellow and green, it's generally an irrigation inefficiency, quite often from not enough pressure or not enough flow getting delivered. It could also be a badly designed system, but that's less likely. The pressure reducers can be fitted to solenoid valves or after solenoid valves, and even to houses now. Every house has a pressure reducer. What are we gonna do? I was going to start talking about design before the break, but what I'll do is I'll just finish this properly, then I'll get the design into the next section. We should be all right for time. So valve boxes is something that you probably aren't dealing with. You're not dealing with residential valve boxes, I wouldn't imagine, most of you. The valve boxes have been kind of this like uneventful space for a long time until Rainbird introduced their new valve boxes probably 10 years ago. The picture on page 25, the lilac topped valve box is a Rainbird valve box. It's got features. Valve boxes never had features. They had a lid, and then they had a box, and they had a bolt, and even then they sometimes didn't even have a bolt. I don't deal with this, you guys deal with this, but like the inability to access a valve box is a pain in the ass, and the ability to access a valve box easily is also a pain in the ass. So I'd be really conscious to be choosing valve boxes that make sense for you guys, valve boxes that are vandal resistant enough that you don't have people going in and turning solenoid valves on because they want to water the local park near their house for, say, Australia Day cricket match. I've never done that, but I wonder who our clients has. But also that they're not damaging things and stealing things, but also you need to be able to get in there if you need to. Valve boxes come in green and lilac, so they're the same differentiators as non-drinking water and drinking water. And I really like those Rainbird valve boxes. I don't know what they're like to install, but they're quite strong. They've got a good base, so they sit well. If you drive over them, you don't crush into the ground. You can stack them on top of each other, so you can make a deeper valve box. And then they've got those little inserts that you knock out. Has anyone installed them? Like, yep. Do you find that the insert knockouts is beneficial, or is it more of a pain in the ass? They're good, and you can just slide them back and try and, So yeah, you knock the inserts out, slide the pipes through, instead of having to cut the valve box with a recip or a grinder or whatever you've got, steak knife, I've done that before. Then you can kind of slide that bit back on and then wrap it with plastic. Valve boxes, their core purpose is to give you access to the valve when you need it and protect the valve. And so we don't want dirt coming in. We don't want them to be able to be driven over and crushed into the ground. And that's why we put bricks under them. And that's why we buy strong valve boxes. But then, yeah, the ones you see on the left of that picture are residential valve boxes. Same deal. You want to be able to access them. They're less likely to get driven over, and they're less likely for someone to kind of get in there, unless you've got one crazy child. But he's been pretty good with it lately. So mainline is the next section. There's a photo that's our photo. I didn't steal that. We actually supplied that. It's very exciting. Obviously we talked about the lilac pipe being important. we're starting to see a shift from solvent weld PVC across to electrofusion welded metric pipe, so the coax pipe that I talked about before, which is a mains pressure, flexible, stretchable, it's not stretchable, but it's somewhat malleable pipe that gets joined together using compression fittings or electrofusion fittings. Electrofusion is where we weld the pipe together effectively. The fitting has metal in it. We heat the fitting up, it melts the plastic that is the pipe. The fitting and the pipe all become one, and effectively that joint is stronger than the pipe was. We've probably been part of the reason that's changing. I think that being able to deliver a roll of pipe, and half of you probably hate me because of it, but because you have to roll these pipes out. But I just think it's longer lasting, it's more flexible, there's less, you're not dealing with glues and primers, which I think at some point we're probably going to discover that the amount of glue and primer you've had on your hands in your life is probably not contributing to your health. I think we'll probably move over to electrofusion welding as a primary, or at least compression, as a primary way of dealing with things. The golf courses we're designing now are predominantly blue line Cs. There's less PVC on golf courses than ever. Yeah. I think the cost of pipe is lower, but the fittings are higher. But I think the benefits are they definitely outweigh the cost of the install. Another interesting thing and I don't know that this will happen in your world, but in the golf world, they're ripping blue line into the ground using plows. So they'll go buy 63 mil or 110. I don't know if they can rip 110. I haven't seen that before, but and they'll basically have it on a vibrating plow, and instead of digging a trench, they'll drag the pipe into the ground. So they'll do a whole fairway, so 300 meters, and they'll just join it all together, and then they'll go expose that pipe and do the valve sets and then run the pipes out. So it can be a lot faster. I don't know what the impact on the pipe is, because they tell me that they leave the ends sticking out of the ground for a little while because the pipe contracts back down. So they obviously stretch this pipe. I don't know what that means for the fittings, but it's being done a lot, especially in Queensland. And I haven't heard negatives about it, but I just don't know. Pressure reducers and filters, I talked about that. These are if some people choose to leave double or dual checks off of a system, people also choose to leave pressure reducers, air release valves, and flushing valves, because they're perceived to not bring any value, and they're probably a cost that if you're trying to do a discount irrigation system, you would choose. You can't leave sprinklers off, right? Some do, but you can leave the pressure reducer off and the system will still pop up, but it's just not as efficient. I think there's a false economy around that. I think that the more efficient, especially in your world, right? We're dealing with millions of litres. And so if we can make a system 5% more efficient because of the quality of the system or the way we manage the delivery of the water, so from a controller standpoint, we're doing better financially. And obviously if we're in a drought state, we're almost always in a drought state, we're being more responsible with that water, and that's important. So pressure reducers, as I mentioned before, will determine the pressure that's coming out to the sprinkler. You can put a pressure reducer on a valve. You can actually buy sprinklers now that are pressure regulated, so they'll have it in the shaft of the sprinkler, so they deal with it at their own level. The sprinklers I talked about before that we need to buy from overseas have that in them. They're handy for when you're doing a really long run. So these specifically are going on a verge. I think the run lengths were you might not have seen it, but 150 meters or something. I'm looking at Mudge over all of you. I know you guys don't know the answer, but it's ridiculous. So if you think, if you've got a 150 meter long sprinkler run, the sprinkler here and the sprinkler at the far end, if you pressure reduced here, there's a massive difference because you've got that pressure loss through that pipe. So that makes sense. Air release valves are designed to let air back into the pipe when you turn a system off and let air out. When you try to force air into pipe with water, the air compresses. Water won't, but air will. So the idea is that we use air release valves to let the air out of the system, otherwise we can get damage. And then flushing valves, exactly that. They're designed to flush a system out. So you can get automatic flushing valves and they'll just actuate every time. We tend to avoid putting them in because they're probably the first thing that goes wrong, and then all of a sudden you've just got a system flushing for 12 hours rather than the 8 litres or whatever it was meant to be. And then So we have a manual flushing valve, which we'll talk about in maintenance, but the idea with a manual flushing valve is that someone needs to go out there seasonally, check the system, open it up and flush stuff out. But if you put everything in as required, put tape over your pipes, do your joins cleanly, flush the system when you install it, use mains water and have a filter on your valves, the chances of you having any need to flush your system is really, really low. And so if I was leaving that off, or if you chose to leave that off, I'm probably not going to be too critical. There's a sprinkler chart there that I'll touch on quickly. Effectively, you've got spray nozzles, which are the traditional spray nozzle on page 27 on the top left-hand corner. They're the ones that we were selling back in 2000 to 2005. Every house just had them, you know, MP, what are they? Hunter PSO2s, a lot of you would know them. Then we've got the rotary nozzles, which have kind of come into play recently, the ones that throw the finger spray. Both of those are probably more of a residential spray, but they get used commercially sometimes because they have to. Their vandal resistance is not great. An MP rotator head is quite easy to steal and it's very easy to kick off. If you're going to be looking for vandal resistance, because there's really no vandal proof sprinklers, Toro do this sprinkler called a 640, which only pops up a little bit. It's got a brass rod in it. Playford had it, or have it and have it, have it and had it. They're stupidly expensive and you have to pre-order the angle, so it's a pain in the ass. But they're relatively vandal resistant. I think you can buy 4 Rainbird 8005s or 6 Rainbird 8005s for the same price. So my recommendation would be try to find the best balance of price and vandal resistance. And then you've obviously got impact sprinklers. I didn't even include impact sprinklers in there because I don't think you should be using them. I think they're stupid, but I get it if you're doing a temporary irrigation system or a market garden, that kind of thing. Drip irrigation, I will say about drip irrigation, I would recommend that you do not use non-pressure compensating drip tube. I would recommend that you use ideally, I mean, one of the beautiful things about the irrigation industry is that what we sell, a lot of it has air in it. And because of that, a lot of it's made here in South Australia. And if not made in South Australia, it's made in other parts of the world. So our Dry Creek location has a pipe manufacturing facility next door. So the pipe we sell you is made in Dry Creek. So we have 19 mil, 13 mil, 25 mil, all of our blue line. The coax I mentioned before with the purple on the outside, it's all made locally. Drip tube is made in Victoria, so the Netafim drip tube is made there and brought over. I think Toro still, I think they might have shut it down now, but Toro were making their drippies in Beverley up until recently. The difference in cost from a pressure compensating drip tube to a non-pressure compensating drip tube isn't much, but you'll get more efficiencies. A pressure compensating drip tube, all that does is it ensures that no matter where a dripper is on the line, it delivers the amount of water that it says it should. So Netafim's generally a 1.6 litre per hour per dripper. The sprinkler example I gave you before, where there's a sprinkler 150 metres away and one here, if they get the wrong pressures, you might find that the spray pattern changes and that the water being delivered slightly off. A pressure compensating dripper has a rubber diaphragm inside the dripper that ensures that the water at the other end of the drip tube is being delivered the same as the one at this end because the pressure changes. The issue with that not happening is you get variations in water. If you were growing grapes at a winery, that would matter. Gardens, maybe not as much, but as I said, the cost is not much to go up to pressure compensating, so we encourage you to use that. Drip tube is really important that, again, if it's a lilac system, use lilac drip tube. Sensors, this is too big to talk about. There's a lot in sensors that can be installed now, flow sensors, moisture sensors, water sensors. The technology around that's getting really, really good. I'm probably not the best person in the business to talk about it, but if you are interested in sensors and I guess the developments and how they can interact with your controllers, weather stations, that kind of thing, a lot exists. And I think the guys like Matt, who's probably working out there somewhere now, he can talk to you about that. System integration and control. I don't even know how to cover that off, but we talked about how controllers talk, so that's fine. And then the last thing, there's the critical South Australian requirements. That was the picture I was talking about. Pipe on left with cross is no, pipe on right with tick is yes. You probably could get away with it. No one will ever call you up on it, but I would strongly suggest you do not use lilac striped pipe when you should be using coax, because if you don't get signed off on it, it's going to be a very expensive exercise. I think we've gotten pretty close to 10 o'clock. We will break now. If you guys can be back seated at 10:30, enjoy some coffee and some food, and then we'll move into design. Thank you. During the break, I spoke to a licensed plumber who just wanted to highlight a few of the gaps, truth adjacents. So backflow prevention devices need to be tested every year, not every 2 years. I got that wrong. He also mentioned that the OTR, which is the Office of the Technical Regulator, are becoming more concerned about irrigation being installed unlicensed. I'm getting conflicting information from the Office of Consumer and Business Affairs, and so that's obviously not a surprise to me and probably anyone here that the two hands aren't talking to each other, but it's my expectation that they probably won't come down too heavy. It was his that they might. There's a commercial reality that without irrigation installers, there's no irrigation being installed. Without irrigation being installed, it holds up development. And obviously then houses don't get built. People don't have anywhere to live. So I don't know, I think there'll be a middle ground. They might have a bit of an amnesty, I don't know, but important to be across. Also, the staff here said that it was quite cold in here. I didn't feel it because I was presenting and it was quite hot, but I'm sorry if it was. They've put that heaters now here to help. So if you're still cold, then it's probably you, because we've got two. Then it shouldn't be a problem. So she did say if the front door gets left open for extended periods of time, similar to a backflow prevention device for stopping a breakage, that the air will get drawn out. So does anyone have anything they want to say or any questions from the morning session? No? We shared a cookie, and I think next time we do this, we're going to probably get Subway cookies. I've still got mine. So, all right, so I'll get straight into it then. That took a bit longer than I thought. As I said, we haven't delivered this training before, so I also add a lot. I guess there's things that I think of as I'm talking, but I think those first two were important, but probably not why all of you are here. And I think that design is probably one of those pillars that's interesting to a lot of people. So we've got an hour and a half or less now till lunch. I'll try to focus on the most important and practical parts of design. I really want to talk to you about the high-level understanding of irrigation and precipitation, as well as design principles that we use. I'll try to avoid going into too much detail about things that we can do for you. Obviously, we have 3 designers here today. Caesar's walking around helping people out. But we also have other staff here who do design on a daily basis for residential and small commercial work. And then in our stores, we probably have another 10 people that are capable of design at different levels. It's a service that most irrigation businesses provide free of charge to a certain level, and then they charge. So we have a kind of a blend of both. We do a lot of free design work if we sell the irrigation, but then separate to that, we have a design arm that does charge designs, which we may not supply. It is our opinion and belief that it's best practice for irrigation systems to be designed separately to the supply. We've started to see commercially a lot of systems that are being specified as design and construct. It's a commercial decision being made by developers because it reduces costs sometimes, but sometimes puts at risk an avoidance of specification and then a reduction of quality in the system in some cases, not always. And so we would encourage local government, if possible, to get a design done so that you've got a standing piece of what you want done and then go out to tender on that, rather than getting a design and construct. As much as a specification exists, if you give me an hour, I will find savings against any one of your specs. And it will be around changing of procedures or changing of quality, moving things around. There's a lot we can do. So design's an interesting process. It's an art and a science. These guys are artists that have to use science in their process. As I mentioned earlier today, everything we sell has data behind it. The sprinklers that we supply have been tested in wind tunnels to determine how far they throw, how much water they throw, how much pressure they need to do different things. The drippers that we supply have pressure compensation so that they get delivered the right amount of water. There's a lot of physics involved, and that's why we do those pressure versus flow tests before we do designs. In saying all of that, I could give these three the same design with the same spec, and we'll probably get 3 different pictures. And all 3 pictures are fine. All 3 pictures will work, and all 3 pictures meet the specification. It's just the nuances that occur when a tree is there or a small bit of lawn pokes off of a large bit of lawn, and they'll just manage it differently. And that's one of the great things about having a team the size that we do, is that they can actually work with each other to decide whether or not that might be right or might be wrong. There's varying levels of experience. Caesar's been designing irrigation since before some of us were born, but you've got that bounce off point to go, hey, what do you think? And yep, we'll change that. And again, harping back on the fact that we have a store as well, we've also got people inside the store that have had a lot of experience that then they can go reference. So I'm going to talk to you about all of the design related things, but I'm going to try and move this screen into a PowerPoint presentation without exposing any confidential information. Okay, we're done. So design. Obviously, I probably should introduce Caesar, Luke, Sarah. They're the design team. We are on the hunt for another designer at the moment. We're actively trying to recruit. I expect we'll probably hire 2, and we'll have a 5-person design team that handles irrigation designs, audits, and consultation. Chris isn't here. Chris is actually doing his other job. So they have a person that's involved called Chris who runs our DC store. He's not here, but he has touch on a lot of what they do. So when we're looking at an irrigation design, not dissimilar to specification, it's really important to focus on what the goal is or what the end is before we start. And what I mean by that is, what is the result that we desire? How do we want this irrigation system to deliver? Are we looking for a top quality irrigation system that has an 85% or higher distribution uniformity? We'll talk about that later. Or do we need something that just gets us through? Are we looking at a temporary irrigation system that's going to be ripped out in a month because we're just trying to establish hydroseed? Whatever it might be, it's important that we start with the end in mind. And I've got behind me a tiny irrigation design checklist. This is a version 1 of a piece of paper that we've introduced in the business to capture all that information. Because too many times they'll start a design and then they'll spend a day on it, and then we'll get an information change. And this is the same kind of thing that happens on site, and this is why I talked to you about specs being important. This is why I talked to you about recording your pressure versus flow tests. Regardless of if you're right or wrong, it takes time. And in our case, if we're right, it doesn't matter because you're our clients. And so we eat it and then we start again, and it takes more time and it costs us money, but it continues to build the relationship. So we capture all the information before we start the design with the end in mind. And that information leads into the design. Now, the information that I'm referring to is pretty detailed, and it's all referenced in the book. We need to understand your needs, wants, and desires as a client, but we also need to understand the physical limitations of a site, the water flow, the pressure, the electrical availability. We need to understand watering windows. We need to understand when and where water can be applied and when it can't. We need to understand the quality of the water and whether or not it needs to have additions or subtractions, I guess, filtration. Now, the site conditions, the core one there is around an accurate site measurement. So we would look to capture, as a priority, a GPS file. So a GPS plotted site file, accurate to the, I don't know, 10 mil or something, like pretty detailed. If we can't get that ourselves, we would be supplied with a file from an architect that's had playgrounds and other things designed. Worst case scenario, and it's not preferred, but it is often done, we'll design from an aerial photo, and then we'll just resize that photo. The problem with that is obviously when we get out to site, things aren't exactly right. So, because the Earth's round, right? Okay. No? Yes. So we capture all that information, and then we understand what the client's requirements are. Now, I talked quickly before about watering windows. We have varying accepted windows, and for a house, it's not a big deal. Your sprinklers come on in the morning for an hour, you've probably watered your house for the week, everything's fine. But if you're looking to irrigate the foreshore at Henley Beach, your watering window is heavily reduced because there might be yoga or activities at 5 a.m. and then there's still activities happening at 10, 11, 12. And so the window we have might be a 4-hour window, and we need to deliver a certain amount of water. Now, they need to take that into account when they're designing the system, because if we put a system together that requires, I don't know, say 7 hours a day of watering, which is not uncommon. A golf course could be, 12? Like, you're almost watering if there's not players on the course. If they don't know that, then we need to change how we design things. And so we need to potentially have an increased amount of water availability, or we need to be conscious of how we schedule that irrigation. So a golf course, for example, they would start watering the holes that are being played first earliest, and then you might, for those of you that play golf, you might find that you're coming around the 4th or the 5th and you're seeing sprinklers and you're kind of chasing sprinklers. What did I do? Oh, it's a bit out of focus still. Okay. It's not the person, it's the tech, right? Cool. So watering windows is something to be taking into consideration. Obviously, budgets is a massive one. So we did a golf course design 3 years ago, and I think Matt might have been in the meeting with the superintendent, and he said, I want my whole fairway to come on all at once. So 500 metres by whatever it is, 20 metres, all at once. And we said, yeah, that's fine, we can do that. It's probably going to cost a bit more, but if you're happy with that. And we went through the process, and we ended up that I think we had 180 mil main line on a golf course, which is less common. I think even bigger potentially. It might have been 300 at the start. And these aren't exact numbers, but for context, if a normal golf course irrigation install at the time was 1.5 million, we were looking at about 3.5 million to install the system that he wanted, because the pipe was so big. Now, it meant that he could water the whole course very quickly, but it wasn't important enough to the golf course to have a quick watering or a whole hole being watered at once to pay an extra $2 million. So we need to understand all those things, and they're probably things you haven't thought about or things that you're not conscious of, and that's the importance of today, just to understand why we ask those questions and why my team is so insistent on this getting filled out before we get started. Because and I say this to my sales team all the time, one sentence from you can be a day to them. And just saying, yes, we can do that, or yes, we can make that change, or that's fine, it doesn't matter, like they'll just do it again. It takes them a whole day to redo it. So if we can capture that information correctly at the start, then it ensures that we can do a good quality design. Future expansion and modification is a big one. We do a lot of work with developers. Riverlee's is a great example. There's guys here working in that site at the moment. We have a conversation with them about stage 50 while we're designing stage 1, because they're bringing in entirely new infrastructure just for that suburb or that, the expansion. And if they don't have an understanding of what's going to be required at the end, then they're not bringing in the right amount at the start, and then we can't do things. And that's when we struggle with water. And that's what's occurring as we kind of squeeze more houses into residential areas. We start to impact things like available water and flow, but probably in that case, more importantly, stormwater, and how we manage the reduction in areas that catch stormwater rather than send it away. So all of that's important. And it's funny, when you talk to golf course superintendents specifically, they'll tell you that their job would be easy if it wasn't for golfers. But the reality is, without those people and without the residents that live in your councils and the golfers that play on the courses and the teams that train on the football grounds, we wouldn't need the grounds, and in turn, we wouldn't need people to look after them. So it's an interesting connection, and without them, you guys potentially wouldn't have a job. And so we just have to work with them to make sure that we deliver the most efficient amount of water at the most, reasonable price for their expectations, whilst taking into account the expectations of the people using the area. So I know that's probably a bit of a long way of saying it, but the pressure versus flow test I talked about before, I'm going to play the video because I think it's important. I might just do it fast because I'm conscious of time, but we, as I said, do a pressure versus flow test on a site. A lot of you might have done this. This is me in a much warmer day.
I'm going to teach you how to measure your pressure and your flow.
I might just turn me down a bit and fast forward it. Is that?
Hi, my name's Clint Adams, and today I'm here at Waterpro.
I don't know if anyone else's kids use their
on our garden tab.
login for
This is a kit
YouTube,
that we have available here
but I was
at Waterpro,
expecting there to be
and
a
our clients
full
use it to
stream of
determine
Roblox stuff down the side there, but not too bad. So
the
the device I'm holding in my
one,
hand there is a
you need to
pressure
mount
versus
the
flow
pressure
test.
versus
It's
flow
one
kit
that we
to the water
make.
source that we will be
So
using.
we buy all
It's
the
really
parts and put it
important to
together.
use the water source that we
You could
want
make this
closest
yourself,
to the
and
area
there's
that you're
obviously
irrigating, so
varying
you have the most accurate
sizes. This
The
is
kit I
quite a
have here
small
today
one, I guess, if
has
you look at it, but that
multiple
yellow
parts.
hose that I'm holding
is more
in my
likely to be
right
used
hand
on
is
a
about
commercial
32
site
or 40
when
mil.
someone might need to go
If you're
into a
testing the
valve box to
water
get
flow
access to
or
it.
pressure from a
Today,
40 mil
we will just be using
meter,
this
it's really
and coming
important to
straight
try
off
and
the
keep the
So
sizing
the
up
kit
there.
comes with
If you were going
various
bigger,
things
we've done
that you
some
can
where we've
use,
had a 50 mil piece of
in any
PVC
situation.
coming off of a backflow
Today I'll
prevention
be
device.
mounting a 20
This
by
is
25 mil
the water
bush
source
to the garden
closest
tap.
to the irrigation system. So this is an irrigation system that we're going
See,
to
there's a bit
design
of thread
a
tape
little bit
on the tap.
later.
That doesn't
That's
matter.
lawn, that's
If it
garden.
leaks
It's in your
slightly, we're
book.
not
You can
too
look at it.
concerned. We're just using this for testing
We need to
purposes.
test the water flow
Now, the test kit
closest to
has
where
this
we're going to
barrel
use it. We're
unit
not
on
going to test the
which
water
means we can fit
adjacent.
the
I
test
think
kit
you had,
through
I
that
wasn't
thread
you. We did
without
I went to a
actually
site the other day
having
and we couldn't
to
test the
turn
water,
the
so I
whole
think
test kit.
Caesar tested the house,
So
someone's
it'd be
front
interesting
yard.
to see how
like,
tight this goes.
just some
I do have
random
some
Waterpro
multi-bits
dude in the
available.
front
You
yard,
might
but
need to use
we
them
need to
if,
test
you
the
do
water
find that
closest to
there's
the
small
system
leaks,
for
or maybe
obvious
you don't have
reasons.
the hand strength
Things
to
change
tighten
the
that up
further
tight.
away you get, but
So
what I'm doing there is
currently I have water
mounting
flowing
the pressure versus
freely.
flow test. There's a digital meter on that measures the flow, so that I know this is hard to see, and next time we'll do this in like an amazing hotel. But
As you can see, I now have the pressure
this
versus
is all we
flow
got.
test kit mounted
So
to the tap.
that digital flow
This
meter will
gauge
tell you
here
the
is a
flow
pressure
that's
gauge,
passing
which
through there,
measures,
and then the pressure
water
gauge
pressure,
will tell you the pressure that it's at. And so what we do is we adjust that ball valve to change the pressure. So we want to get pressure versus flow readings at a few different readings. So in the book it says 25%, 50%, 75% and full. We also want the static pressure. So the static pressure is when the ball valve's turned off completely, how much pressure's in that main. Then we open the ball valve up and slowly let water out, and we might find that we get the pressure gauge to 250 kPa. Then we measure the flow at 250 kPa. Then we might open it up a bit more, and the pressure might go down, but the flow goes up. And so we get these three data points, and then my team can use that to design irrigation systems because they have a good understanding of the flow and pressure. As mentioned before, this is a device that you can borrow from us.
One will be completely open. One will be at a certain pressure, say,
or you can buy one, or you can make one yourself.
One may be at
if you're doing big commercial projects, I'd probably suggest getting a larger bore tester. I don't know if we had a photo of it, but when I was doing the research for this, I found we had a wheelie bin and a large one that we would use for commercial flow. I mean, if you're testing, the flow coming out of here would
we
have
can see here
30 litres a minute.
We've got about 70,
we
69
would
to
test
70 litres a minute
200, 250 litres a minute out of a 50 mil water meter. So as you can imagine, a 10-litre bucket's going to be full in a second, so a wheelie bin's a more appropriate way to manage that, or you just spray it off into an appropriate water storage area so that you're not wasting water. There you go, 38.
And all you do is adjust this ball valve.
So that's how you test the pressure versus flow. You capture that information, and then we take that. Now, the next thing in this document talks about CAD design. So the team design irrigation systems using CAD. I'm just going to take you back to PowerPoint
bring it into the irrigation shop, and the team will use that information.
So the team design the irrigation systems in CAD.
If you've got any questions about this or anything
design irrigation systems in IrriCAD.
Do not hesitate to get in touch.
I'm still talking.
We are here to help.
Well, me and Mike got called out here for a
pump guy. So they design in CAD, as I said 5 times, and you can also design in IrriCAD, which is the software that's separate to that. We don't use that. Or you can design on paper. For a long time, before I had Waterpro, I used to design irrigation systems by hand, and I'd do commercial irrigation systems by hand. The theory is no different. You're plotting a sprinkler. So in this case, we're going to work out where to put sprinklers, where to put drip tube, where to put pipe. We just do it by hand. The advantage of doing it the way they do it now is that changes can be made digitally, and you don't have to draw it from scratch. And also you can make multiple copies. It can be integrated with, the building documentation. There's so much more to it, and I think design will evolve even more. I think, unfortunately, Royce, who just left us, was a Revit user, which is 3D I guess this is a layman's way of explaining it, but 3D CAD. I think that there will be a point where irrigation design is designed as a 3D model and it can be installed into the 3D setup. So you've got the furniture and all the pipe work and all the infrastructure and all the cable all on the same plan, but we're not there yet. And I don't think our industry's got enough volume or profit to warrant the development of that. But they design in CAD, you don't have to design in CAD. Another advantage of designing in CAD is that we can produce as-built documentation. And so this is something that's probably not being done well either, but when a job gets completed, one of the hold points should be as-built documentation. So you'd have the contractor come out, meet you, or they'd have us come out, we'd bring our GPS out, and we'd physically go plot every sprinkler, every valve box, and we'd draw the drawing as it was installed rather than as it was intended. The advantage of that is you now have an asset register that you can store that information and you understand where everything is. I know Adelaide City Council have been GPS plotting their backflow prevention devices because they just didn't know where they all were. There's so much infrastructure in your world, and obviously the guys that are installing it, it's different, but there's so much to remember and you can't be expected to know. And well, the hard thing is usually it's one person that's been there 40 years knows where all the backflow prevention devices are, but you can't rely on the human brain to remember that. You know, that person could be away, they could be sick, they could just not tell you because they hate the government and they're like over it. But if you can store that information digitally, then you've got that record, and it means you can start to create maintenance plans, which we'll talk about later. So we would do an as-built documentation, and then that would get handed over, and then kind of everything's been checked. When we design an irrigation system, well, when I design an irrigation system, they might be different, but we work from the delivery of the water back. So we would work out what sprinklers go where and how much drip tube goes where, and then we work backwards. And we'll talk about this in the next half of design, but you need to understand how many devices can operate on how many valves and what size pipe to deliver. You can't do that the other way. So what we would do is plot the sprinklers, work out how much total flow they require, check that against the flow that we have, and then go, okay, we can put 2 or 3 sprinklers per valve. Which ones work best? Do those 3, do those 3, do those 3, and work backwards. So all of this is connected to simulated rainfall. So you'll hear people talk about precipitation, and the Hunter MP rotator, the MP stands for matched precipitation, and precipitation is effectively rain or the falling of water. And in the irrigation industry, it is our job to simulate rainfall using artificial means, but more accurately. So the idea is that we deliver the right amount of water to the right area consistently across an area when desired to meet the requirements of the plant. So when I was talking to you about the 6 pillars, that's one kind of framework. The other framework, and I haven't completely built it out, but effectively the whole design and delivery and scheduling of irrigation is about understanding the needs of a plant, what they've currently got, what was taken from them the day previously due to evaporation or growth, and then we replace it. And we keep the right amount of water up to the plant. When I say plant, I mean lawn or plant. And we keep the appropriate amount of water that's there to either meet a budget from you around we've only got so much water or we've only got so much money, or the plant's requirement because we've got a standard. So IPOS being the Irrigation Public Open Spaces Standard, like what do they need? How much water does this plant require in millimetres per period to achieve a certain standard or a certain look? And as I mentioned before, the irrigation materials that we design with have all that data. So we can go design a system and know that that system delivers 10 mil per hour and the site needs 25 mil per week. Therefore, the controller needs to operate for 2.5 hours per week to deliver 25 mil. We'd like to do deep root watering, so let's do that on one cycle, or we'd like to do that over 2 cycles because of watering windows. It all connects back to that. And so what I will do is talk quickly about precipitation at the most simple level, and then we'll move into a live design. So I better not do what Dylan did and use the wrong markers on the right board. So precipitation, as I mentioned before, is, I guess rainfall. So 1 mil of rainfall on 1 square metre equals 1 litre of water, right? So when we're saying last night we got 10 mil, if we had that evenly falling over 100 square metres, that's 1,000 litres of water fell on that lawn, but each of those square metres got 10 litres of water. This all connects back to irrigation design. So if we had a 10 metre by 10 metre section, like I said, 100 square metres, if we had 10 mil of water, you've got your 10 times 100 equals 1,000, and that's litres. It's also mil, it's 1,000 mil, which is 1,000 litres. This formula is used in working out catchments as well for rainfall. So if you had a property in the hills and you needed to get some rainwater tanks and you wanted to understand how much water those tanks could take per period, you could look at historical data from the BOM and understand how much rainfall falls on average over a period, and then you can accurately size those tanks. Because you know that your house is 100 square metres, we have, 240 mil a month, therefore we can get, 24,000 litres over the month. We use some, so you've obviously worked that out, but it all connects back. And so we do a fair bit of content, and we do a podcast, and I had a call asking to explain this, how would you do this with a hose, right? So if you had you didn't have an irrigation system, you don't want one, you're renting, you water your lawn, we supply a wetting agent called Wet, which requires 10 or 11 mil of aerial rainfall. Are you okay? Yep. 10 or 11 mil of rainfall, of precipitation to water in the wetting agent. If the wetting agent isn't watered in properly, it will burn your lawn, and then the whole world melts. So if you wanted to do that by hand, all we would do is go backwards and work it out. So we've got 100 square metres, we need 10 mil, so that's 1,000 litres. How much water comes out of our tap per minute? It's 30 litres a minute, right? Pretty standard, 20 to 30 litres a minute. All you need to do is divide your 1,000 litres by 30 and get your 33. I stole Matt's calculator, actually. I could just use that. It doesn't work. So you basically divide that by 30, and it is 33.33. So for 33 minutes, you run around on your lawn and evenly water exactly the same amount per square metre. You've delivered 10 mil of precipitation from a garden hose. Done. Now, that's crazy and it's not accurate and no one's going to be able to do it. So that's why we design irrigation systems. And the idea is that we design an irrigation system that no matter where you go on that lawn, it's had the same amount of water, because these guys, or you, have put the right sprinklers in the right spots with the right pressure, watering at the right time for the right amount of time, all good. Now, obviously there's things that impact that, such as wind and rain and vandalism and the sun and slopes and soil types and all this other stuff. But we get as close as we can, and that's why we have a distribution uniformity of 85% that we're chasing. But the reality is most sites are probably running 55 to 70 if they've been around for a while. And when that happens, all we do is water for longer to make sure that the bit that's getting the least amount of water gets the same as it should. So all of a sudden, if this bit's that bit's getting half the amount, we need to double the watering. That gets 10 mil, everything else gets 20. So that's when we start over-watering to try and help cover an inefficiency, and that's when we start spending too much money on water. So, the design process. We collect all the information, which we've done. For this design that we're doing, I wrote this all down. I did prepare. In your book, there is a live design exercise on page 39. Now, I've kind of drawn what it is over there. What do we got? 55 minutes. So, irrigation, we'll start with the lawn. So, when we are doing something like this, we would sit down with the plan. So we've got a scaled plan. We've captured the information that we need to do the design. So in this case, the client's told us that there's a 40 mil water meter and that's delivering 120 litres per minute at 500 kPa. So that's the pressure, that's the flow. That's fully open. Then we go, okay, how would you like to irrigate that? So obviously this checklist has that information. We've got the water source, which is a 40 millimetre. We know the flow. Is there a backflow required? Yes, it's already installed. Was this tested before or after the backflow? After, cool. So the backflow is not going to impact that pressure because they need to take that into account when they're designing. They're going to lose 50 kPa through a backflow on average. No worries, we need to install another backflow to meet some compliance issues. That might go down to 450. And then they talk to the client and say, what's your specification or what's your requirement? What's your desire around the irrigation? They're like, well, we are a council that uses rainbird sprinklers. It is our preference that we use 8005s, which is not able to be seen by you over here, but if you need to, I can bring that out. But we're happy to use 5000s if we need to. We like to use 8005s because they're a stronger sprinkler and 95% of our sites have that sprinkler. We like to keep it consistent, but we acknowledge that they throw a fair way. So, excuse me, they'll sit down and go, how do 8005s fit? And they'll look at these charts. These are all available on the internet. So if you're one of those Matt Irving style guys that kind of gets off on irrigation, you can go download these and keep them in your desk. This will say that we're saying we've got about 450 kPa. They'll design it to a bit lower. They'll design it to 350 because, and I'll just to go through that again. We've got 500 at the water meter. Sorry, I need to be over here, don't I, Dylan? We've got 500 at the water meter. That 500 goes down to 450 after it goes through a backflow. But as it moves through a master valve, a solenoid valve, a pipe network, elbows, T's, and gets to the sprinkler, it's probably going to shave another 100. So they're going to start going, okay, we've probably got 350 kPa at the sprinkler, that's good. If that was the case that we only had 200 kPa at the water meter, sprinklers are off the table. There's not going to be enough pressure at the sprinkler to pop the sprinkler up. And so we need that pressure at the sprinkler. So if that was that line of 150 metres that I talked about before, that last pop-up needs that pressure. It can't be halfway 350, it needs to be 350, well, whatever it is, it might be 280, but if it doesn't have the pressure, they won't pop up. We can't use the system as it is. Then we have to look at putting in a tank, which some councils will be like, that's stupid, we're not doing it. Just design with a smaller sprinkler or just put drip tube in because drip tube has a lower requirement. So Caesar and his team will look at this and go, all right, so we can throw at 350 kPa with a nozzle number 10, we throw 16 metres, and nozzle number 8, we throw 15. This design was conveniently sized to make my life easier. It's 30 metres by 60 metres. I know that's a square. You know what? Is that a square too? I think that's even worse. That's more of a square. Just imagine this is a rectangle. So, oh no, which way does it go? 30 down the sides. So 30 metres down that side and 60 along there. And so we look at that and go, the sprinklers that are available, how do they fit? Now, if that was, I don't know, 27 and 48, it would be a pain in the ass. And that's why I've done it this way, to teach you the basics. And then obviously, like I said before about it being an art and a science, when they get those complex measurements, that's when they go through this process of going, well, can I fit that or do I need to do that? In CAD, they've got this beautiful ability to build a grid and just dump it on top of the plan, and they can move it around and kind of see where they'll sit and see how it makes sense. The way I used to do it in the early 2000s was I'd get a compass and a ruler, and I'd sit the compass next to the ruler and get 15 metres, and I'd start kind of drawing it and seeing how it makes sense. We don't have to do that with this because it's such an easy shape, but we're looking at 15 metre gaps because the sprinklers work quite well in this area. You could divide 12s into these, you could divide 10s into these. This is all the stuff. Remember at school when you're like, when am I going to need this information? This is when you need that information. Like the compass one really blew me away. I never thought I'd use a compass or a protractor, but here we are. So the 30 metres, if you divide that into 15, it's obviously done, there's that, right? And if you divide it into 10, Then it's going to be, what's the gaps? 6, so 7. Sorry, not 10, 10 metres. Yeah, so there'll be 3 gaps. So then it would be like there and there. So you'll have a sprinkler there, a sprinkler there, a sprinkler there, and a sprinkler there, or the one that I did before. I did 2 pictures because I knew I was going to confuse this. And so they go through the process of trying to understand what sprinkler best suits the job. And in that process, they look at the flow and go, at 350 kPa, an 8005 throws 16 metres, but it needs 35.43 litres to do so. Now, we'll never design out to that 120. So how does 34 fit into 120? And I think it'll fit in nicely. It's 102. We can deal with that, right? We'd try to go down 20%, you know, maybe a little bit more. But we can fit that. So then we can fit 3 sprinklers on that flow, and we can have them throwing the further distance. So we could put them there, there, and there. And then we do the same process that way. And it's quite often when they're designing, or when I'm designing, I'll start in the corners first. So if you had a shape like this, that's really small, I'm sorry, I know this is not the best to see, but we'd start designing in the corners first, and then we'd work out, okay, well then we can just finish these. And I know that I make that look quite simple. We do this every day. So usually they can just look at, especially the guys that work behind the counters, they can look at most backyards and they just see it. It's like this instinct. They just go, no, there's one there, one there. Especially now the yards are getting quite small. And I mean, the only downside is when landscape architects start doing fancy shapes. But, you know, sprinklers don't go round corners. So when I had my backyard done, I actually made them change it so that it fit the system. So my lawn's only got straight edges. But I'm a weirdo like that. So we go the other way. So we've got 60 divided into 15. So there's 4, which means 5 sprinklers. And then we just go through the whole process. So we put the sprinklers on. Oh, I screwed that up. And so we've got 5 down there. Is that 15, 30? Yep, cool. And then we've got 3 that way. And then the idea is, and the reason we're doing this, a sprinkler needs to be the radius of the sprinkler away from the other sprinkler, plus some. So these are 15 metres apart. We'll probably give them 16 and a half metres of throw, because they get impacted by things. And those, the quarters and the fulls and the halves are obviously all passing different amounts of space at the same amount of time. And so the next process they need to understand is how these get paired together. Have I missed anything? You happy? Cool. I don't do this as a job, so I'm expecting some meetings afterwards. It looks shit. Just say it.
5 by 5 sprinklers.
5 by 5. No, that's 30 metres. It's just not to scale, because I'm not a designer. So anyway, yeah, I probably could have done this better. So the next process is, how do we make these sprinklers connect back to the mains? Because we've got 15 sprinklers. We've worked out, because of our maths before, that we can run 3 at a time. So that works out well, right? The problem is, you can't put a quarter and a full and a half all on the same valve with the same nozzle, because they don't pass the same space the same amount of time. So if you think about this here, that one there, that does that 4 times why that does that. That does hit that. So we need to be considerate of the fact that that sprinkler's doing 4 times the passes of that, and then twice the passes of that, and then we adjust the sprinklers to suit. And that's how we get the matched precipitation. Because if you think, I mean, that makes sense, right? Like if you had a catch can there and a catch can there, and they were all running the same amount, this would have 4 times as much water as this, and this would have 2 times as much water. But then you take into account that they're all overlapping each other, and then all of a sudden you don't have matched precipitation. Now the MP rotator, which I spoke about before, that alleviates that. Those nozzles have been designed, if you use a 1, 2 or a 3, in any configuration, so 1,000, 2,000, 3,000, in any configuration, the precipitation matching, if it's being designed head-to-head like this, is taken care of. If you don't design head-to-head, what happens, and we had a Verge, this is a while ago now, we had a company come in and said, I'll translate it into very basic terms, we don't give a fuck, we just need to get paid, and I'm not doing it, just put the sprinklers here, and we'll just water for twice as long, or 5 times as long. We're not paying for the water. That was the translation of what was actually said. Sorry? Bold? Cold? Sorry. Is everyone warm now? All right, so we're good. So these things are 5-star review. So what happens there is these sprinklers do that. And then these areas get missed, and then these areas get watered by 1 sprinkler, and these areas get watered by 3 sprinklers. And so you've just got all these inconsistencies. And so all you're doing is you keep the sprinkler system on until the bits that have no sprinklers get flooded, and therefore the bits behind it are even more flooded. And that's hard to see, but you get the gist of it. So if we're not using match precipitation nozzles, we need to make the nozzle selection make sense. I spoke to Matt about this yesterday because, full disclosure, I didn't remember some of this. And he said, because I said, can't we just use match precipitation nozzles? Because the Rainbird 5000 has MPR nozzles and they just do the work for you. And he's like, I won't say what he said because it was coarse, but he said the spray is not equivalent to a human urination. And so I said, okay, well, what does that mean? He goes, I would prefer that we try to design with good design practices rather than relying on match precipitation nozzles in sprinklers that don't do it that well. And so what we would do is we'd work out what nozzles to use. This doesn't work perfectly because of the size, but effectively we'd go back to our chart and say, if we are doing a full circle irrigation at X, then we want the half circle to be half X and the quarter circle to be a quarter X so that the passes they do all equal to the same amount. It's not always perfect, and when we can't do that, what we do is we start matching the sprinklers to the valve. So we didn't need to do this nozzle thing. We could have just gone, that sprinkler and that sprinkler and that sprinkler all go on a valve together, and then that sprinkler and that sprinkler and that sprinkler all go on a valve together, and it doesn't work. You'll just have this mess of pipe, and it doesn't follow best practice. So we try to design it so that they're paired perfectly, but we also try to make sure that we're sending nice, clean lines of pipe through and we're not jumping. Like, I mean, you imagine you're walking across a small thing like that. And this is probably a bad size example, but if you go to an oval and then there's a sprinkler on one side of the oval and then one that side of the oval and one on that, it doesn't make sense. It works and it's completely fine, but that's not how we do it. So we do all that, we work out which sprinklers go with which, and assume we've nozzled these down. If we nozzle these perfectly, it makes complete sense to me that we run a main line down that side and we just do 3, 3, 3, 3. Then they'll size the pipe to make sense. So obviously we have friction loss through pipe. I'm not going to explain this, I'm just going to draw it. But we need to make sure that the water pipe, the main line that's running down here, is big enough that this last sprinkler here is getting the right amount of pressure. And we've designed this on 350 kPa, so they'll do calculations where they work out how big that pipe is. Then there'll be a valve there, it'll go through there, but they need to make sure that pipe's big enough, and then that pipe will get smaller. So that might be 40 mil PVC, that might be 25, that might be 25, that might be 20. That all gets calculated. Then we know how many valves we've got, because we've just worked out, I know this is a mess, but I'm trying to move through this fast. So we've got a solenoid valve in 5 solenoid valves. So we've got 5 valves for irrigation. Then we need to work out drip tube. So drip tube is a separate process, and I'll go through that now, and then I'll talk you through the cabling and how we do that. I'm trying to find a balance between getting it all done and having tacos at 12. Has anyone got any questions or any comments? I might have made a mistake. No? All good? No questions? He's out. Sorry. You're all good, man. Like I said at the start, if you need to leave, it's all good, I understand. This is the best bit though. So when we're doing garden beds, we are able to design them somewhat on square meters because they're consistent. And so what they'll do generally is hatch an area and work out the square meters. So this outside area is the garden bed. Because I designed this in a certain way, I know that the garden bed is a certain size. And I've documented that somewhere. It's not here. I think the whole area was 3,200. Yeah, so the garden beds are 1,400 square meters. So what I'll do the workings on this board here, just so it's easier to see. That's my cookie, I don't want to use that. So what we do is we can work out how much drip tube fits an area using we don't actually have to physically draw the drip tube. We can divide it out and we can work it out. Now, one thing I probably didn't cover off that I should have was that when those sprinklers have all been designed, they will have a precipitation, which is what we talked about before. And all of that information is here. So the precip on a 3.510 is 16 mil an hour. So if they're designed in a square grid, that system is delivering irrigation at 16 mil. We talked about 10 before. If we want to get 25 mil, we're just multiplying that by a different number, 1.5 and a bit. Drip tube is an interesting one. Drip tube's obviously available in lots of different brands, and where am I at? The one that we see the most commonly used in irrigation systems in South Australia is a 0.4 by 0.4 spacing with a 1.6 litre per hour dripper. Now, I think somewhat accidentally or not, that's really landed nicely as a 10 mil per hour of water delivery. And when we do work, like design work, I think Playford specifically, but others are probably asking for it now, the valve table, which is the spreadsheet that we build out to explain what everything does, so valve number 1 is this and does this, the last line will say it takes 42 minutes, 60 minutes, 73 minutes to deliver 10 mil of water. And that information's pre-calculated so that it's easy for them to schedule their irrigation requirements. 0.4, 0.4, 1.6 is 10 mil. 0.3, 0.3, 1.6 is something like 17.6 mil. We've got 16 mil with these 8005s. MP rotators do about 10 mil. It's important to not put too much water out at once. A lot of the soil, especially parts like Playford that I mentioned before, are so somewhat hydrophobic or clayey that they can't physically take that water. And so what happens is it sits on the surface. And so we try to we take that into account when we're designing. But the beauty about 0.4, 0.4 is it keeps it cost competitive. If we go too far out and start going 0.5, 0.5, the drippers are probably starting to get too far apart, and then we are relying on the capillary action of that water in the ground to merge. Because when we do that, when we water 0.4, 0.4, we are basically having drippers every 400, like a sprinkler, right? But instead of the sprinklers doing this, they just have irrigation kind of flood out and join up. And by doing that, it doesn't matter where you plant a plant, it's going to get water. Pretty much the right amount. Obviously, there's micro things happening like rocks and roots and soil differences, but the general thing is they're going to get the right amount of water. And so when they're designing an irrigation system for drip tube, they take the total number of square meters, in this case 1,400 square meters, and then they divide that by 0.4, which gives them the meters of tube, which is 3,500. There's a lot of calculations in the back of this book, and these are also available on the internet, or you can use an AI. But if we've got 1,400 square meters of area, you divide that by the spacing of the tube, as in how far apart the tubes are being spaced. So in this case, it's 0.4, and you get out to 3,500 meters of tube. And then we divide that by 0.4 again, and that tells you how many drippers there are, which is 8,750. So we've got 3,500 metres of tube, divided by 0.4 is 8,750. And each of those drippers puts out 1.6 litres an hour. We talked about that before. And so that system is taking 14,000 litres per hour. And as we talked before, we have 1,400 square metres, therefore 10 litres per square metre per hour, therefore 10 mil an hour. So that's the process of calculating the flow. Instead of someone standing there with a garden hose and watering that area for a long time, the drippers do the job for us at the rate that they've been predetermined, at the rate they've been designed by these guys, and you know that if you turn that on, you can get 10 mil an hour. Again, all this information should be at the back, plus we're filming it, plus it's Googleable, plus ChatGPT just owns it. So you can find this information. In saying that ChatGPT is not good at designing irrigation systems, you need to continue using professional irrigation stores like Waterpro. I'm serious, I've been trying, don't worry. I wouldn't tell you, I'd just do it and charge you for it. So once we know that, we can then go, we've got 14,000 litres an hour. Is that right? Someone take a photo of that and run it through some AI for me. No, there's 8,750 drippers. Oh, that's litres per hour, sorry. So I have to divide that down to minutes. That's what's freaking me out. So we need to get that back to litres per minute. So we divide that by 60, which gets us to 233 litres a minute. I was looking at like 120 valves for a warehouse. So then that divided by 60 equals litres per minute, and litres per minute is the space we're playing. So I was trying to work out how many valves to put this on. So it worked out to 233 litres per minute. Obviously, 120 is almost exactly double that. I wouldn't let these, well, they wouldn't even ask for my permission. They wouldn't put that on 2 valves. It would go on 3, right? You're not going to design right out to 120. It's pretty close. You need to take some considerations in things changing, the building being used for other things, whatever, car wash opens up next door. So we'd probably put that on 3 valves. In saying that, commercially, they generally don't design above 50 to 60 litres a minute per drip valve, right? Which is about 300 square metres, 350. The reason is when we go up above, like if we just did this on 3 valves and we were trying to push 80 litres a minute through a system, 25 mil poly can't handle 80 litres a minute. And so now we're looking at putting in PVC as a header pipe. So this may or may not be something that you're across, but when we do drip tube, we have a pipe at one end, which is a delivery manifold, and we have a pipe at the other end, and then the brown drip tube. I need a shelf. All right, so the brown drip tube runs between them. If that needs to handle more than 50 to 60 litres a minute, it can't. And so then we've got velocity issues, which I talked about before. And the problem is it's a lot more complicated to install 40 mil PVC header pipe, because that's what you'd have to use effectively, with rubber grommets and takeoffs than it is to just add another valve and put 25 mil. And we probably championed this change in Mount Barker, Bluestone stage 2, so like 2010 or something, because it was so much harder for the contractors to perform the work than it was worth getting so many valves on a line. But also, if you think about it, if you want to do drip tube on a roundabout, you need to put 40 mil PVC header pipe around a roundabout. And 40 mil PVC doesn't bend like that. So we started designing smaller valves. It means that there's a 25 mil valve. It means that there's 300 square metres of valve. It means that sometimes that more than one valve might be on at once, but with central control capabilities, it's possible. And look, if someone had an alternative suggestion to that, I'd be happy to listen to it, but we are trying to take into consideration everything. We're trying to take into consideration The watering windows, we're trying to take into consideration the requirements of the council, but we're also trying to take into consideration the capabilities of the people installing the project, but also the capabilities of the people repairing and managing the project once it's been finished. And we found by keeping it there, it's fine. Anyway.
So if you guys keep the drip stations at 60 liters per minute or lower, they will save the troubles of going to the 40 mil PVC header.
Yep.
But also, you will not need another filter, because most of the filters,
Yep.
the maximum flow they can handle is 70 liters per minute.
Yep, that's a good point. So what Caesar was saying is it won't just reduce the need to have larger pipe, but it will reduce the need to go to a bigger filter, because most filters can only handle 70 litres a minute. And so what happens is we start putting bigger valves, bigger filters. We've got bigger valve boxes, bigger footprints of valve boxes in open spaces where we shouldn't see them. So like I said, if there's a better solution, I'm happy to listen to it, but that's how we do it. So what we've got here is now we've got 5 sprinkler valves, 3 drip valves, 8, we could go to 9 core, right? We could use a 9 core cable because 9 core can do 8 valves. We would probably put either a 9 core and a common in, or we'd put 13 core in. And it just gives you some flexibility. Not that it's likely to change, but it's always nice to have that cable. So the valves for the drip tube would be split probably evenly. So that what these guys would probably do is split that up, and they'd water like that bit, and then they'd water that bit, and then they'd water that bit. And you'd probably have a header pipe here, and then you'd have one here, and here, and then you'd have one here, and here. And it's really important, if possible, to run your drip tube long ways. And it's important to run your drip tube across a slope. If you don't run your drip tube across a slope, you run it down a slope, you'll find that sometimes the drip tube becomes a bit of a slippery slide for the water. The water won't touch the soil and it just goes down the tube, and you basically send all the water to the bottom. So we would have 3 valves for that, like I said before, and we'd have the valves there. Those drip valves, you might have them on the main line, so that main line I drew there, you might have a drip valve there, and then you might have 2 down here, because you might have 2 here and 1 there. That's up to them to decide, but that's the gist of it. So then, and it's hard for me to show you this without the parts, but it wasn't practical for us to do it. So what happens then is the irrigation controller goes down here, because there's power down here, and then we run cable up to all the valves, and then there's a controller on the wall here. There's a backflow prevention device here. The main line doesn't need to go back there, so the main line just goes from there across, and then these valves come off the main line. They send pipe down through all the sprinklers, and then they send water out to the drip tube. Anything else? I haven't missed anything? Makes sense. Residentially, you'd probably put a lot of those valves in one box together. Commercially, we keep them separate. I mean, they're obviously 15 metres apart. It just makes it's just more of a standard, it makes it neater. And so once we've got all that together, then we can basically install the controller, run the cable, and wire it all up, and then you've pretty much, your system's done. Now, we talked about nozzle selection and pipe sizing. So with pipe sizing, we basically put the smallest pipe we can without affecting the velocity of the system. So we don't oversize pipe, because obviously that becomes a cost concern, but we make sure that it's the right amount. So there's a thing at the back that talks about velocity. It's right at the back. I don't need you to go looking for it, but I'll just explain it to you. So when we're designing irrigation systems, we're trying to keep velocity below about 1.5 metres a second. I think sometimes they'll push close to 2 if they have to, but they don't like to. Like I said before, velocity in pipe creates water hammer, but it's also a friction loss concern. And so they'll design that to whatever's appropriate. So this system was 120 litres a minute. I'm guessing probably 40 mil main line, maybe 50 mil blue line. Then we might run a 40 mil lateral for the first sprinkler, and then a 25 for the second sprinkler. They know that. I don't know, but they'd know, like from instinct. There's not too many new designs coming, like nothing new's happening. We either design an oval, a soccer pitch, a racetrack, a council verge. Like it's all, they're seeing a lot of the same stuff a lot of the time. So golf courses, yeah, what's that? Helicopter pad. Have we done that? That's pretty cool. I'm guessing not concrete. Cemetery has a helicopter pad. I'm just trying to think what the upgrade is. Like you just fly in? I could understand if it was a wedding venue, but okay. And so once we've built that out, we've installed the controller, we understand the amount of water that we need to deliver. We can start looking at the scheduling of irrigation. And so, like I talked about before, we would go to the local government or the whoever owns it and say how much. Well, actually, we don't get involved in scheduling. That's up to you. But we get involved in giving you the information that you require to schedule properly. So, as we've said here, these areas will do 10 mil an hour of water each, and the sprinkler does 16. And so then you can work out, not only, there's a few things you can work out from that. You can work out how much water you're actually going to use. So this can help you from a water budgeting standpoint. If you understand how many square meters you've got and how many mil an hour each square meter is going to have land on it, you know that this lawn, which was 1,800 square meters, I think, yep, times 16, is 28,800 litres an hour, which is 28,800 litres in an hour. And so you can multiply that out by whatever it is, and you'll find that, okay, for us to irrigate this lawn at 25 mil a week, we need to use 35,000 litres. And we find it's quite interesting when you have, we'll have residential designs, they'll come in and they'll say, oh, we've got rainwater tanks, so we should be pretty cool, right? Like, we've got a 1,000 litre tank, that'll water the lawn for like a month. And the reality is at 30 litres a minute, as we worked out before, it'll water the lawn for 33 minutes. And so sometimes putting a rainwater tank in isn't actually, the cost benefit's not there. A lot of the rainwater tank installations is around water security or environmentalism, because you're not, in the smaller scales, you're not going to get the return on an investment for the cost of the tank and the pump. So then once that's all done, the council can obviously, or even residential client can then work out how much they want to water based on the requirements that they've been told. And it's just a multiplication, which is at the back of your book. If you've got 10 mil and you need 25, it's times by 2.5. And obviously if you've got 16, that's about 1.5 something. Now, I'll just talk about controller wiring inside that. I think it fits here. I've got to talk about installation as well and make sure that we're finished for lunch. I don't know if you guys saw the taco truck rocked up as we were coming in. Yeah, they're probably still cooking. I'd say it's nice, slow cooked. There's even, I think there's like a jackfruit option for those that aren't meat inclined. So the wiring of an irrigation controller is something that I will talk about because I think it's important. So I talked to you about decoder controllers before. I closed that. I've closed that. That's it. There's no open loops there. So with irrigation controllers, you've got the decoder controller, which I talked about, which sends a signal. But a traditionally wired controller is the one that you're going to run into the most. And so they have these ports on them. If you go back, and you don't need to, but if you go back to the book you were looking at, there was the little irrigation controller. You'll usually have common, and then you'll have a master valve, and then you'll have 1, 2, 3, and so on, depending on how many they are. And they might have a little screw underneath them, like a Phillips head screw. And then you're going to have a manifold of valves. So I'll put a master valve in for the benefit of this because I think it might help. But if you have your manifold come out like that and you've got, say, 3 valves, the coils might not be on the right side, but just bear with me. Like I said, I haven't worked in an irrigation shop for a while. And then a lot of solenoid valves will have red cables, but it doesn't matter what colour they are. So each of those valves has 2 cables coming off them. And if they're the same color, it's because they're an alternating current valve. So when you wire them up, the polarity of the electricity doesn't matter. If they had a black and a red, it's very likely that they're a direct current valve, which is like the Hunter nodes, those 9-volt latching coil valves. Those valves, the polarity matters, and if you wire them up the wrong way, you're going to have a problem. This, not so much. Now, as I mentioned before, we would wire in the black as the common. And so you'd have your red cable, your red sheath cable coming off. A common wire would go out to one of each of the valves. It doesn't look like that, but then you've got your wire joins. They also don't look like that. A master valve, you can choose what color you want to use. I don't have a lot of flexibility here, but then you would wire the other side to that. And then you just work through your colors and join valve 1 to valve 1 and valve 2 to valve 2 and so on. And so the way the irrigation controller works is, as I mentioned before, it's got a 24-volt alternating current transformer in the controller that transforms the electrical power down to goes from 240 and it transforms it down to 24-volt alternating current. And so when when a traditionally wired irrigation controller, there's no colors. Dylan, what's going on? Can everyone kind of see that? You guys can't see it. Yeah. We should have done discount seats on that side. So, for those that are colourblind or can't necessarily see this, that's black, that's blue, that's green, that's orange, that's brown. Those colours don't matter. We do traditionally use black to wire to each of the valves as a common. When an irrigation controller, I've just screwed up the video, haven't I? When an irrigation controller needs to turn a valve on, it sends electricity down the common and the active, and it makes a circuit, and then the coil, which is on top of the valve, lifts up using an electromagnet, and as long as that coil stays up, the valve stays on. The water that's behind the valve opens because it's forcing through the diaphragm. When that pin drops or the magnet drops, the valve turns off. So if someone cut that cable during the cycle, the valve would turn off, and if the electricity stops going to that valve, the valve turns off. You can also simulate that action by turning these coils. So you can open a valve manually because you're lifting the pin manually. So the electrical process is being replicated manually. When a master valve's in play, it actually sends power down the master valve and the common as well as the active. So you'll have the master valve turns on, water flows in, then valve number 1 turns on. Valve number 1 might have a pressure reducer filter, and then it sends water out through pipes to the drip tube. At the end of the drip tube, you might have an air release valve and a flushing valve, and that's kind of the system. When we do the second one of these, which is going to be, well, you guys probably won't want to come because it's the same, but I'm going to have a big picture of an irrigation system. It will be much more visual, but anyway, sorry to tell you that. I'm just disappointing, aren't I? So that's how an irrigation controller works. In a DC version, we still wire up the 9-volt controller to the coil, and you just have the polarity matters. So the red cable goes to the red cable, the black cable goes to the black cable. The difference with a 9-volt latching coil is it sends the signal through, it latches the pin open, and the valve stays open until a signal gets sent back to turn it off. And that's why 9-volt batteries don't go flat after an hour, because they're not being used for the whole process. They're only being used to open the valve and close the valve, whereas this traditionally wired controller is sending electricity down the cable the whole time. Make sense? Cool? You knew that, didn't you? No? Cool. This is good. You're learning. All right. Now, I think that's probably it from a design standpoint. I wanted to talk about the cable. The drip tube that we drew is being installed evenly spaced. One thing I didn't talk about is when we're putting these drip tubes 400 apart, we want to bring them in 200 from the edges, and we try to make that work as best as we can. We don't want to bring it 400 in from the edge. That was 10 metres, so we'd divide that out and we'd kind of work that out. It's important to try and keep those pipes tight, keep them straight, use metal pegs, roll the drip tube off the roll the same way it would have gone on the roll to keep it straight. Keep your pipes clean, have tape over the ends. Don't join a joiner into a dripper. So if you've got a dripper there, just cut past the dripper so that you're not trying to shove a joiner into a dripper, because that's not going to work. But that's the gist of the design side of things. I know that's a lot to take in. I feel like I haven't given it enough justice, but I just wanted to give you a general understanding of precipitation and sprinkler usage. These people do it for a living, and so do a lot of stores. Like most irrigation stores will do design for you for free or charge. And if you're not sure, obviously lean on these guys. We've got to do installation before lunch, so I'm going to move into that now. We've got 15 minutes. Be interesting to see how Taco Cartel handles 110 people screaming. I mean, they've probably done festivals, right? So once we have a specification and a design done, it is installation time. Now, as I mentioned at the start, I have not installed irrigation for a long time. I'm not a manual labour guy. It might not be visually obvious, but I don't like digging, and I don't like trenching, and I don't like getting my hands dirty. And so I had an irrigation installation business for a period of time that very quickly turned into an irrigation supply business. On days when it's raining, it's nice. Well, we don't make any money, but it's nice. We stay inside. But I do feel like I can talk to you about installation somewhat. So the first thing that's in here is around the installation is the material staging. And I guess this comes back to, let's start with the end in mind. And that's kind of been the theme of today, but also business for me. And so it's important to be conscious of the fact that there's lots of different ways that a system can be installed, and some of those, the things that impact that you might not have control over. I mentioned before that there was a site that we were working on that they had no water meter. So they can install their main line, but they can't connect it to anything. And so the process changes. And we've got contractors that love to put their sprinklers and their laterals in and work backwards towards a valve and then work out to the main line. And we've got we've got a bunch of contractors that will choose to take the main line, the cable and the valves, and they'll put them out first and then they'll move in. It doesn't really matter what order you go in. It just matters that you meet the specification and the design. Now, the product staging is important to be conscious of because we can do a lot of different things. We can have a shipping container full of irrigation shipped to another state or a regional area. We can supply you with the mainline cable and valves and hold the rest of the stock in our warehouse. We can just trickle stuff out. We can support you however you want. We try to pack our orders in a sensible way so that when you open the box, you are pleasantly surprised by 2 or 3 Chubba Chubs and the fact that the valve is with the nipple that's with the ball valve. That all makes sense. We don't always get it perfect, but we try. If you're buying irrigation from us and you're buying staged irrigation, just think about what you might need. Think about the security of the site. Think about cable. Cable's a big one. You know, is it going to get stolen? Is it a problem? We can support you however we need to there, but I just encourage you not to necessarily take more than you need, but also be conscious of making sure that we're aware of what is going to be required so that we can forecast that. We've got a very large warehouse at Dry Creek. We can hold a lot of irrigation. We do hold a lot of irrigation. And if you need us to support you around the supply of it, then we're there for you. Now, I've harped on this ad nauseum today, but the next step, and possibly the step that you might need to look to do before buying materials, is do a pressure versus flow test again. Everything that we've talked about today, the specification, the design, it's all connected back to the pressure versus flow. And so go do that test. I did talk to you before about the wheelie bin and the big hose. That's the photo on page 41. Don't do a pressure versus flow test on a 40 mil water meter with a 13 mil hose. You are not going to get accurate information and you're going to find that you have problems. Now, once you've got your pressure versus flow test sorted out and you're comfortable that the irrigation supply is managed, you could either do this yourself or you could engage us or a similar business to come out and do a GPS mark out. So if the irrigation system's been designed professionally using CAD, then it's very likely that the business that you're working with has a GPS device. And what colour paint do we use, Caesar? Not blue, not green? Not green. So you want to find a suitably trained GPS person to come out with a paint that's visibly able to be identified in grass. And then they'll come out and mark out the irrigation system. They can mark it with flags for sprinklers and that kind of thing. Are they causing trouble? Yeah. I think we've probably reached the edge of your attention span, to be honest. It's all right. We've got 10 minutes and it's taco time. And so you get the GPS done, and then obviously having a suitably qualified, and I'm giving him shit. He is a suitably qualified person. He just made a mistake. You want someone there that understands what's meant to be on site, because the GPS will tell you something, but then he'll look down the line and go, that's not right. That sprinkler's not in the right spot, and he'll go sort that out for you. So you get that sorted. Obviously, as I said, I'm not a contractor, so I can't tell you how to do this, but I think it's a good idea once you've got that sorted to do a site walk, understand things that you might not have seen, like there's no water meter here yet, or they're building a toilet block in the middle of the oval and I'm meant to be putting something there. Get your dial before you dig sorted. Make sure that your site is safe and secure. Cable's something that we've mentioned a lot, but a 500 metre roll of Dakota cable goes, that buys a lot of drugs. And so the recommendation is to try and get all your cable in all at once, or bury the cable or similar. Or you could have, it's probably worth having a security guard, to be honest. Now, I was a bit apprehensive about putting in this next section because I felt like it was almost a little bit too basic, but there's a bunch of information there about tools that you could use to be an irrigation contractor. And you will probably look at that and say, you've left about 10 off, dickhead. It's there because this is meant to be a comprehensive guide. The idea with the basic thing is to highlight to you that you can really, really easily become an irrigation contractor by buying a few tools. It doesn't mean you should be an irrigation contractor, and that obviously goes back to the licensing side of things. It also highlights that you could become, if you want to become the best of the best, there are some tools that you could be buying that you probably haven't thought about. And we sell a lot of electrofusion welders, but I'm not hearing a lot about people doing ohms resistance testing, and I'm not hearing about GPS units being used. So these are just some ideas if you were, considering going to the next level and you wanted to manage all of that yourself. You could buy these tools, and then obviously, we're pretty flexible with time, but if you don't want to wait for us, get your GPS file, and you can do it yourself. Now, I've got a bunch of pictures there which I've stolen from Adelaide City Council. Again, please don't tell them. No, they're available on their website, so it's not so bad. But the only way I could really talk about installation in a room where we're not installing was to try and use this, the visual design guides. And there's a heap of information in there around all of the things that you should and shouldn't do. But the reality is, while you're installing, all of this information is in the spec or it's on the design. And if it's not, someone's made a mistake, and I would strongly suggest that you go ask. Matt, who was in here, has just left, is a massive advocate for nothing should be on the plan, right? The plan should be the plan and everything else should be in the spec. And we see it a lot where there'll be something around, refer to the plan, refer to the plan, refer to the plan. It's our goal that it's on the spec, and really the only thing that's on the plan is where the sprinklers are going, where the controller's going, what the size of the pipe is and that kind of thing. But the reality is sometimes it's not. Now, all of these pictures and all of this text is in there to highlight to you that it is important to install systems a certain way. Residentially, you could probably do whatever you want. You might just make sure that you dig it down far enough to get it in. But commercially, you need to meet these specifications. And if you don't, you might not get caught, but it's not best practice. And if you don't get caught straight away, you might get found out eventually. And the reality is, as you all know, Adelaide is a pretty small place, and that information travels pretty fast. Now, there on page 48, which is the picture we had up before, there's the valve box installation. This is probably something that would catch people out a little bit more than other things. I think it's important just to be conscious of the fact that your valve boxes are at the right grade, they're at the right angle, that the ball valve can be turned on and off, that they're accessible, but they're not too easily accessible. If they are meant to have bricks under them, they have it. If they're meant to have plastic around them, they have it, and that they're doing what they're designed to do. We see it so much where the valve box just gets thrown over a valve and it almost gets backfilled and the valve box just becomes part of the soil. That's not what they're designed for. And if you're doing that in commercial projects, you're probably going to have to do it again. Sprinklers, same deal. Right height, not tilted. You'll notice in the picture on page 49, there's an articulated riser in there. they're there for a reason. They're there so that you can adjust the height of the sprinklers, but also, especially in Adelaide City Council, there's a lot of vehicle traffic through those areas. Those valve boxes need to be installed in a way that they can handle that traffic. Those sprinklers shouldn't be driven over, but in the event that they are, they should survive that if the Arctic's there, hopefully. Now, there's a section in here about specialised techniques. What's the taco time? Oh, we've got some time. There's a section in there about specialised techniques. I obviously can't go and show you them now, but I'm going to talk to you about them because they're really, really important. And as I said at the start, I think there's a possibility that we might do a hands-on training for anyone that's been to this once you've got your certificate, which is not nationally recognised at all. But once you've got your certificate, then you can come and do the hands-on stuff if you want. Electrofusion welding is something that's going to become part of your day-to-day it would be already. And if it's done properly, it's beautiful, but there's so many things that can go wrong if you're not doing those 1%ers. And I mean, we could do an hour and a half training on electrofusion welding, and we have done it. And as I mentioned before, on YouTube, all of those videos exist and you can go look them up and you can find them. But the reality is those 1%ers, there's probably 10 or 12 of them, such as cutting pipe straight. You're not getting dirt or debris in the pipe, cleaning your pipe appropriately. And when I say cleaning it appropriately, I mean removing the outer layer as well as not getting skin, hair, dirt, anything on there. Because the cleaner that joint is before it starts, the better it's going to be. And cutting out an electrofusion welded joint is a pain in the ass, and you're now having to do multiple joints. So if you follow, there's a picture there on the left that one of the contractors we deal with has installed. Again, I'm not an installer, but I think dig a bigger hole than you need, and then it's much easier to be neat. That's obviously that on steroids, but just make sure with your electrofusion welders that you're using an appropriate power source, that you're running it for the right amount of time. There's usually a barcode on the fitting, so you can scan that, and then the device that's doing the welding will actually understand what it is and it will do it. Let it dry properly, take into consideration weather, don't do it while it's raining. There's a lot of that, but if you tick all those boxes, you'll be fine. Now, moving on to wire joins and electrical connections, I've probably talked enough about that before. It's really important that your joins are clean and that there's no water getting into the electrical componentry of an irrigation system. Obviously, as with decoders and that kind of thing, it's going to cause potential problems if you don't do that. The decoder lightning protection we touched on before, each manufacturer that requires decoder grounding has different requirements. And most irrigation design firms will just say, you work it out. I think we try to put the decoder grounding points on the plan. Yep. There's different ways to do it. And the idea is that you're grounding the system in a way that if lightning strikes the system, that you don't lose the decoders. When I say lose them, that they stop working. Decoders are an expensive component, but also the labour of then finding them and reinstalling them is a problem. As I mentioned before, I think that there's going to be lightning protection free decoders at a point, and I think that that's going to change the game a lot, and it's probably going to reduce the cost. They're available now. So, and again, I don't work in irrigation shops anymore, but I think that will start to reduce. It'll make the barrier to entry for residential decoder systems more likely, but also that you're not going out there and dealing with those. They cost more, of course they do. Yeah. So Mudge has just given me the Spondula signal. It would make sense that they'll cost more because they're a good technology. Yep. So I'm getting 5-minute taco hand waves. So who's excited? Has anyone left yet? So decoder systems, again, like with everything, if they're installed properly, they'll work well and they'll work fine. It's probably the thing that we're seeing done least well is the decoder grounding being done and then the ohms resistance testing being done. We have a device to do that. We don't really do it that much, I don't think. I mean, we have that as a service, but I really encourage local government to be requiring those tests to be done if you value the asset, and you should, because it's an asset that belongs to your community, but also for the contractors to make sure that they're getting that right numbers there and that they're installing that correctly. The next section is about installation challenges. I'm not going to really go through that. You guys would know more about that than I do. And then the last two things there are around quality control. So the next section that we're going to go through after taco time is audits. And we have had early conversations with one council, and I think that more might come, that around us auditing systems upon completion, which might be a frustrating sentence for contractors that might be, disturbed by that. But the reality is the best contractors won't care because they know that their systems are done well, and that the audit just confirms that. There are a few things that you can be doing, like I said, with that mainline pressure test to make sure that the main line is holding pressure. You could also do some distribution uniformity tests on a brand new system to see how that matches against the theoretical data from the design. And you could potentially look at changing your specification to allow minimum standards so that if the installation doesn't meet the expected or a tolerance, that something needs to be addressed. So I think that's just worth thinking about. As I said, we'll be back here at 1 o'clock, at which time I'll talk about the last two pillars, and then Scott Muller from HR Products will be here to talk about some tools that they have for diagnostics, and then we'll try to finish you before 3 o'clock, right? Anyway, go enjoy your lunch. Thank you. So an audit of an irrigation system, as we see it, is done as a snapshot in time. He took your seat. Now, there's a bunch of different ways that we can audit an irrigation system, and I guess I'm conscious when we do these trainings not to make this a Waterpro sales event, because it's not the intention. And the idea is that we can send you away from today's training with a level of knowledge or comfort that you can potentially do some of these things yourselves, or start the process of learning to do them yourselves with our support. And I think from a local government standpoint, there's a lot of simple auditing that can be done without the need of engaging external contractors. In saying that, I think it's dangerous to ask your barber if you need a haircut. And what I mean by that is if the person that's doing the audit is also the person responsible for doing the physical work to fix the problems, you might find the audit's not done to the same level as if it was done independently. So it might be worth getting someone in the business unit to audit the work that needs to be done by someone else. The advantage of doing an audit is to pick up things that might be wrong in comparison to the installation. So we've talked about specification, so we understand what we want. We've talked about design, we understand where it goes and what it is. We've talked about the theoretical delivery of a precipitation, which is what we hope that it would be. And then we've talked about the installation, so now the system has been installed. An audit done at that period of time will determine whether or not the theoretical installation was done as in a real world situation, and it matches that. And then as time goes by, you could spend, in 5 years or 3 years, you might decide to audit that system again to make sure that nothing's changed. Now, in line with maintenance, doing an audit will enable you to pick up things that aren't urgent and make changes or repairs before they become urgent, both around water wastage and infrastructure damage, as well as distribution efficiency. So a lot of you work with watering budgets, and there's the eyes of thousands of people on what you're doing. Obviously, you pop up sprinklers when it's raining, you're getting phone calls. Being efficient with water matters for a few reasons, and that's one of them. Obviously, the fact that we have limited resources is also important, but also the fact that water is expensive and it's continuing to grow in price. I think it's important to be doing these audits. Now, in the booklet, there's on page 53, we talk about 3 different audits. I don't call them that, and then it's not clinically just that, but it's designed to give you an indication of what kind of audit services we offer and then what kind of audits you could do. And as I mentioned at the start of this section, an audit is a snapshot in time. We do not intend to go back and try and find things that we couldn't find, or wait for something to be repaired and then finish the audit. We take a moment in time and we look at a system and determine what is right or wrong with the system, and we determine what needs to be addressed in that moment. Excuse me. You can do this as well, and so I'll talk about that in a bit. But basically, we can do a comprehensive audit, or you could, which would be including a GPS plotting of everything. A lot of the infrastructure that you have, or that exists in local government, and I'm conscious of the fact that you're not all local government, but the large portion of you are, a lot of that infrastructure was installed prior to being designed, or the designs don't exist, or they were done on a hard copy and they've been lost, or the filing cabinets got stolen, whatever. We can do an audit to produce the, as-built as it stands today. And so we would use GPS for that. It obviously helps with plotting assets, which you can then store that information. I'm not doing my PowerPoint. Does anyone, hang on a second. Dylan, does anyone need the QR code or we're done? When are we announcing that? After me? Before Scott? All right, there's 2 prizes, don't forget. I think they're giving away an ultimate spray pack for the best and the funniest. They'll work it out. I'm getting them to do it because I don't need the backlash. So if you didn't win and you think you did a good job, it's their fault, not my fault. I'm going to bring my presentation up again, somehow. And hopefully we can continue on. There we go. So we're going to get past that. So the level of audit would be determined by the importance of the data that you require. We currently do work for various councils around like full system audits, and they can use that information to determine whether or not they need to budget a new installation or what they might need to repair. But we also do what we could probably call a clipboard audit or a basic audit, which you guys could do. I mean, you could do it all, you just need to learn how to do it. And that clipboard audit would determine things that need to be addressed around, say, sprinklers being straight or being damaged, or valves leaking and that kind of thing. And I believe, if possible, you should, and it would be best that once the audit is complete, you move straight into repair. I think the reality of the way that local government works, we quite regularly do an audit that's used to write a budget for work that will be performed in 18 months. And so the audit that we've done is that snapshot in time, but then by the time we get around to doing it, everything else has changed. Now, I get that it's not practical that could change, but it would be good if there was, and I also get that you have more things to do with less time to do it, and less money to do it, and less resources to do it. So doing an audit's probably low on your list of concerns. But I think that there's an argument that the time and the money spent on the audits will get picked up later because your systems last longer, or you're not using as much water because you're rectifying these problems. So we do the full comprehensive audit. Then there's obviously a middle ground there, which I'm calling standard. So we might not have the GPS involved, and we might not do distribution uniformity tests, but that's really up to you. And the short of the distribution uniformity tests, which you could buy a catch can kit for not much, you could do everything else without the GPS yourself. Dylan, I'm just going to put another video up, if that's all right, just to cause more trouble somewhere. Not there. So I just want to show you a video of us. Oh my God, I need a professional. So this is an irrigation condition assessment.
Assets here, so sprinklers, valves.
Being done by, it's not on, it's not on. Exit full screen of the presentation. I'm trying, man. How are we going? That's Gary. Does anyone know Gary? All right, so that's Irvo. So I won't play the audio again, although he did a great job on the video. So that's a GPS unit in his hand, and the cups that you can see on the ground are catch cans. Now, they're performing a DU, or distribution uniformity test, which measures effectively how well our theoretical precipitation is being delivered. And so they capture that information by filling those cups. And then if you have a look on your page 57, that's one of our DU results. It's quite basic. We capture that information. and then we put it into Excel, and we use that to work out the lowest quarter efficiency against the rest. Is that right, Scott? Yep, cool. Scott's here now, so I can say things and get confirmations. And so the idea behind that is that percentage that we were looking for that I mentioned at the start of the document was 85% or better. And all that means is we want all the numbers to be as close to the same as they can be. And if you see on that document, we've got like a 7 and a 25. They're a long way away from each other. And by doing this test, and so he's GPS plotting the sprinklers as well, and doing the distribution uniformity test, we can report back to the client or to ourselves, or yourselves if it's you, if there's concerns. And you might have some parameters around distribution uniformity that you'd like to meet. And you might even be able to reference the IPOS standards to try and understand what, I don't know if they've got a distribution uniformity, I think they do. But you might be able to reference that document and get an understanding of what matters to you. And then this is just because we bought a drone, I think he wanted to do that. But and then, you know, you can see that sprinklers, it looks slightly angled. The audit process we would go through would be to pop those sprinklers up. Every sprinkler gets popped up, every valve box gets inspected, every nozzle, the pressure gets tested, so we know how much the pressure at the nozzle is, because we talked about that before, that's important. We would note every nozzle, because potentially one of the quarter sprinklers has got a different nozzle to the 180s, because we've done that adjustment. And then we can report that back. So if you look on page 55, we've done that's not our best work, but it's an example, and I was busy yesterday. That's an audit that we did for the Northern Areas Council for, I think it was a swimming pool. And so we produce a plan with every sprinkler. I was going to say, if it moves on to a competitor's video, just yell at me. We go and we measure every sprinkler. We give it a traffic light report as to whether or not anything needs to be done. And then we go from there. Anything that is green is fine. So it would be at the right height. It's not sunken. It's not tilted. It's spraying properly and everything's fine. That plan that you see on page 55, there's a lot of orange. Orange is needs attention, but it's not urgent. And then red is urgent. So an example of something that would be red would be that there's a valve box that's like spraying water out, or a sprinkler's missing, or there's a public safety issue or a damage issue. We kind of invented this. It's not something, I don't know if anyone else is doing it like this, but I find doing a plan like that makes it really easy. And you could do the same, to give to the field staff to say, this is what needs to be fixed. Anything orange needs to be rectified, go out there, or anything orange and red needs to, so, you could go, today you're doing red, and in a month you're doing all the oranges, and then they can go out there and rectify those issues. If a sprinkler is tilted or sunken, or the screw is like that holds the nozzle down is going through the path of the water, or it's not turning, or it's not popping up, all of those things will impact how efficient the system is, because it won't be able to deliver water how it was intended. And so the theory would be that you go fix that, and then you get those back up to the standard. And then you've got, I guess, I don't know, my analogy brain is going to a done-up car, right? Like you've got an old system, but you've given it new paint, new clutch, new engine, whatever else. And those upgrades could be simply a new controller. I mean, the world changes and things become more available. We might not want to use the controller that we were using anymore, or we might want to upgrade decoders. So those audits there, I guess, cover off the three that we see it as, but you could kind of pick and choose what matters to you. You might find that valve box condition doesn't matter, but testing and tagging on a controller really does, because it's been quite a focus of, you know, the people that are making the rules. You might find that drip systems probably don't need to be looked at until something dies, but sprinkler systems, you start to see lawn or grass or turf, depending on what world you live in, starting to deteriorate, and they need to be addressed sooner. You might find that the football ovals that you're using for A grade or whatever standard it is, or cricket, need to be audited more regularly. Most of the information that's in this document will give you an understanding of what you should or could be looking at. It's really just about whether or not it matters to you, and then if you are capable and willing to do it yourself, or you want to engage an external person to do it. I don't think we're the only ones that do it, but you know, it's something that we do regularly. And then you see at the bottom of that table, we actually, in a lot of cases, produce a system replacement cost estimate. So Mudge led some condition assessments for a local council recently where we had, we did an audit and then we just determined whether or not the system should or could be replaced. And then we'll give them an estimate. When we don't install, so it's hard, we give an estimate on the cost of what that might be, and that just helps with budgeting. But for everyone in the room that's not working in local government, doing an audit like this, I mean, obviously if you're in aged care and you've got sites that are suffering, or there's continuous problems, then it's probably worth having something inside your processes where you go audit these systems. You might be doing other things anyway around other safety things that you're there. It might be worth just going and checking that the controller's tested and tagged. The sprinklers are all popping up. Now, I talk a bit about this in maintenance, but that might be something that you do at the start of the season. So you might de-winterize your systems and you'll spend, I mean, I know that for parks and gardens guys, like everything kind of goes off for a long period and then you've got months of trying to, you know, not months, but a month potentially of popping everything back up, making sure sprinklers are pointing the right way, they're still there, they've got the right nozzle, that kind of thing. There's probably not too much more that needs to be talked about from an audit standpoint. It's something that can be done upon completion of an installation, and I think you'll start to see that creeping into the world. We see more often the audit is done on a system that's 10 or 15 years old as part of an upgrade budgeting process, and we probably don't see enough of it being done in a management of infrastructure and protection kind of way. So I think that could be something that people could be looking at. The information obviously is probably best then stored somewhere, and I don't know what systems you have in place for that, but there's a lot of tech evolving all the time, and it might be something that if you do go GPS plot those individual things. I mean, you can get to the point where you could have a GPS location on a sprinkler and know when the last time it was replaced. Because if you think about, like, especially if you're buying, you know, even for commercial projects, if something needs to be warranted, like the sprinkler stops working and the sprinklers, like you're buying 5,000 sprinklers a year, ultimately no one really knows when that sprinkler was purchased because you don't know. You could get to the point where you're tracking the location and that sprinkler becomes a warrantyable thing. You might not care, but you know, an 8005 is what, 70 bucks or 80 bucks? Like that's, you start stacking them together and it adds up. So once you have done your audits, before or after or because of an audit, maintenance matters. And I've said this already today, but an irrigation system is a really expensive piece of hardware to install, now more than ever. And it also is responsible for protecting and or delivering an expensive resource. And obviously, if a system is not working properly, then you're going to be using a lot more water, but you might even be mowing more regularly, and there's costs that go on and on and on. And I don't know what everyone's maintenance regimes are. I would assume everyone would probably like to be doing more, or it would be nice if it was done more, but you don't want to do it. As I see it, there's 4 categories, and they are preventative maintenance, and so that's really getting out there and doing things before they become a problem. And you'll pick that up by doing audits, but it's things like cleaning out your filters and checking that the sprinkler nozzles are actually in place and they haven't been, you know, drilled out and damaged. Making sure that, you know, solenoid valves are in a box that's clean and there's no vandalism. And I don't know how you would set this up, but it would be a case of potentially at the start of each season going out and de-winterizing a system and doing that. Then obviously you've got corrective maintenance, which is once there's a problem. So the orange traffic lights that we have, you would be going out and correcting something that might be an issue. So a valve might be leaking slightly, or a sprinkler might be slightly tilted, or it's not facing the right way. Emergencies speaks for itself. They're the red lights in our audit system. They're the ones that if they don't get dealt with soon, then there's going to be phone calls to complain about something, or there's a public safety issue. And then system upgrades. Obviously, the 4G, 5G, or 3G, 4G upgrades caused a lot of grief for a lot of people. There's no way around that. The reality is that we need to upgrade controllers. There would be other things that occur over time, and then that might just be a case that you're choosing to do an upgrade on something because you've changed the way you want to do things. it's there. Now, there's a section here about seasonal maintenance. Outside of Australia, during colder periods, they would winterise the system by removing the water because in really cold climates, the water would freeze, it would expand, and then you start getting breakages. We don't really have that as a problem, especially here, not in the flats, and to be honest, I don't even think in the hills, but ultimately, during winter, you're not using your systems, and it's probably worth turning them off somehow or some way. It doesn't necessarily mean you need to go out and turn the valves off, but it's probably worth your central controllers getting, switched off, or you manage it in some way. And then the reality of that is that at the end of that season, or the end of the 2 seasons or the season, depending on how early you start watering, when you turn things back on, things have changed. And I think that's really a good opportunity to go out there and start addressing those maintenance issues and making changes or improving things or fixing things or putting the right nozzles in. I think eventually, in a perfect world, if staff stays the same and the budget stay the same and you've got the resources, you can do that at that period, then you might do new installs at that period, and then you might do whatever at this period, and you kind of get an annual cycle to be able to maintain these irrigation systems. I get that it's probably not like that it's not going to happen, and that you're probably under-resourced. So doing that spring startup, and some of you in the room would know this, and a lot of stuff today will be like that, but I just want to make mention. You can obviously go turn a controller on and have it run 2 minutes or 5 minutes per valve, and just walk the site and watch everything pop up, make sure that it pops up, make sure that they're all spraying in the right directions, make sure that there's no drip tube that's been cut and there's water leaking. And in a lot of cases, you can get a remote control for the controller, or you could do it on a phone or an iPad. So it doesn't have to be you running back to an area to turn that on and off. The programming is something that could be looked at. Ideally, nothing's happened because you have not touched it. Residential contractors will attest to the fact that people touch controllers all the time and then lie about it. And so there are contractor functions in some of the residential controllers where you can actually press a combination of keys and it will revert back to the programming that you put in there when you were there last. I think it can really catch people out when the seasonal adjustment has been put to 0 or 200%, and then it starts doubling the run times or zeroing the run times, but also people get confused between start times and programs, and then you can all of a sudden have 16 events happening and there's a lot more water coming out. So I would suggest for most of you, you can probably check that remotely. If not, go through the controller programming and make sure it's all good. So there's a section in there about routine maintenance. I mean, I'm not going to tell you guys how to do your jobs. You guys can work that out. I think it's important to look at. I get that it's not going to always be something that happens, but if you get a good system going, then it will make it easier. So now I just want to talk through a couple of things around troubleshooting problems, and then hopefully that takes about 10 or 15 minutes. We'll then get Scott to set up, and then we'll have that break that I talked about. So when we have a phone call at store level about something going wrong, it's most of the time, it's probably a solenoid valve not opening or not closing, and then the second to that would be that my controller's doing something weird. Usually not connecting to Wi-Fi, or it's turning on too much, or it's not turning on at all. So we talked before about how a controller sends a signal down and all that, but I just want to go through some troubleshooting things with you around controllers, valves, and the things that could go wrong. So when you are troubleshooting, I encourage you to do the least complicated things first and the least labor-intensive things first. And I know that sounds like common sense, but not everyone would automatically jump into that, and you'll find that sometimes people will rock up to a site and a controller hasn't turned a valve on, and so they start digging up valves. And the reality is there's a lot of things that you can do before you need to get to that point. And so I just want to talk to you a bit about that now. I don't think I'll use PowerPoint again. I'm not really good at this. I need someone doing that for me. Where are we? We're there? We'll call it there. So solenoid valves have water and they have power. and solenoid valves won't open as a problem and won't close as a problem. And that's pretty much it. Apart from solenoid valve completely missing, that's it. And so understanding the reasons why these things might happen will give you the ability to go out there and kind of troubleshoot things. Because everything I've talked to you all about how, I mean, aside from you seeing a system together, I've tried to give you a good understanding of how it all works. Not much goes, like if a sprinkler's having a problem, it's because someone's interfered with it or it hasn't been installed properly. Not much can go wrong. If drip tube isn't working, it's usually the same. If a solenoid valve's not working, it's because it's more complex, but it's not super complex. Like I said, this is real simple stuff. And so if you have the two things that you require to open a solenoid valve are water and power. And so if a solenoid valve doesn't open, the first thing we want to do is start checking those two things. Now, if the theory is that we go check the most simple things first, and we want to think about water first, then we just go check if the water's on. And I know that sounds funny, but it could be that the ball valve's been turned off. Or it could be that the backflow is backwards. And that one is a bit of a touchy subject for my team, because it happens. But there's no point getting in the ground and ripping a valve box lid off and pulling a solenoid valve apart to check why the valve won't open before you've gone to check that there's actually water going to the valve. And it could be, and the job I spoke to you about this morning, that there's no meter yet. And it's not, the reason it's not turning on is because there is no water. So these are the things you want to check first. Go check that the ball valve's on, go check that the backflow is facing the right way. There's more than one valve in a system. You might find that the master valve, this is getting more complex, but the master valve's not working, and that's why the other valve's not working. From a power situation, we want to do the same thing. So we want to go look at that and go, well, hang on. We know that a controller sends power down 2 cables to a solenoid valve, and if that happens, then they'll open. Ultimately, you can check that the controller's working, so you can put a multimeter on the points that are meant to be working. If you don't have a multimeter, you could take cables off of another valve that is working and wire them into the same port and check that. And then that will tell you whether or not the controller's maybe not working versus the coil in the field might be damaged or the cable might be broken. Scott will expand on this. All the things that he's going to talk about today are how to test the things that I can't test standing above the ground, just standing at the controller, I think. So this could simply be that the controller's been turned off at the power point, or it could be that it's centralized and the central controller's told the controller to turn off, or it could be that there's a sensor that, so the way a lot of the sensors work is it just breaks the common cable, so the black cable I talked about before, the sensor becomes a switch and it closes that by cutting it. You need to check that the sensor is working. It might be, I don't know, underneath a waterfall, and it's just saying it's wet all the time. So we want to check the power to the controller. We want to check that the cable, we want to check that the controller's actually meant to be on, so it could be a programming issue. And then once we've checked all that, then we can start looking at wire breakages, wire joins, all that kind of thing. And this is one of those things, it's like, when you really understand irrigation, you'll be able to get to a site, and if you're troubleshooting this kind of thing, it'll just make sense. And you'll go through this naturally. You'll be like, yep, that's on, lift that. And you'll look in a box and you're like, oh, the wire joint has come off. Sweet, that was easy, or someone's cut the cable. When you go through all these processes and you don't find anything, that's when it turns into, now we've got like 400 meters of cable we've got to chase, or we start trying to find this more complex solutions. Now, the other side of it won't close. Water, this one could be that a solenoid valve, the most likely thing of a valve not closing is that there's some debris in there. So there's a rock or something under the diaphragm, or the diaphragm's split. There are certain flows that these valves need to close. And I think like a PGV might be 1.5 litres a minute or something, like a 25 mil in that vicinity. So that is something that I learned from Scott in the last couple of years that I didn't really understand or didn't know. And I think a lot of people use the flow control feature on a solenoid valve as a pressure reducer because they think that they can reduce the pressure, and it's not a thing. Pressure and flow are different, and we didn't really talk about that today. The flow control is usually on the top of a solenoid valve. The Toro ones have a knob that you can turn. The Hunter ones, you actually have to slide it. We don't have to, you can put a screwdriver in there and turn it, but it's very underdone. And that kind of techniques, those like to take you to an elite contractor. Like if you're going back and doing that kind of stuff, no one does that kind of stuff. And I guess the point of that is if there's not enough flow coming into the valve for it to shut, it'll just keep dribbling. So the system at that point shouldn't have probably worked that well anyway. And usually we'd see that in a courtyard garden where there's 4 drippers watering pots and the valve opened, but it won't close. The sad reality is if your valve's not closing, this is probably open valve box, open solenoid valve, start looking at it. So low flow or damage. And then the power situation, if it won't close, it's pretty much because it's still getting power. A 24 volt alternating current coil, which we've talked about today, if there's no power going to the coil, it won't lift, so it'll just shut. This is probably an odd one, but if the coil has been turned to turn it on, like a manual turn, as much as it's not necessarily a power-driven situation, it's a simulated power-driven situation, so that you just have to go close that. So controller programming, this could be very much that. It's actually being told to keep working. And also, what is it? Won't close power. It could be the coil. And that's most of it. I mean, I've probably missed some stuff, and there's probably some complex things there. But the whole concept here that I'm trying to give to you is that choose the most simple things first and work through them because you can do that quicker. This kind of thing usually happens Friday at 3 p.m. And you're going through these problems, and then you're looking to try and now you have to go buy a new solenoid valve from a shop, and the shop closes at 5, and you're rushing around. So I think the quicker you can get through those things, the better. I've also put some troubleshooting spreadsheets in there in an attempt to help you with this. This document, I had hoped this document would have been more complete than it is. I spent a lot of time on this, and I think that this will evolve. I was hoping, I think it was wherever Jared is from Salisbury, I was talking to him about it at a barbecue, and I was like, it's going to have QR codes, and you'll be able to like scan that and fly to the moon, and it was going to be amazing. I got it this far. I'm hoping there's enough information in there to get you enough way down the line that we can support you the rest. And that's why those spreadsheets are there. There's a section there around sprinkler troubleshooting. Same deal. There's a lot you can do there. Sprinkler troubleshooting is a lot easier because you can see what's going on most of the time. And then there's an electrical troubleshooting matrix there as well, which we've kind of touched on. Scott will talk a lot more about that when he does his section. What else have we got here? My computer's about to go flat deal. All right, so I think that's it from a maintenance standpoint. Obviously, like I said, Scott thinks his talk will probably be about 45 minutes, but I've seen Scott speak before, so I might give him more runway than he needs, and if we finish early, we finish early. They're the 6 pillars as I see it. I think that, I hope that what I've given you today is enough that you can go out and inspect a system or be part of an installation crew that's installing a system and have enough knowledge now to identify when something's not being done properly or that it needs further investigation, or you have the confidence to ask the question and go, I don't think that's right. I'm pretty sure that Clint bloke said that we're meant to be putting in backflows the right way around. And if you are stuck and you need Waterpro, we're here for you. I mean it when I say it. We're not a transactional only business to deal with. I believe that if we do the right thing in supporting the industry and supporting the people that we deal with, that the transactions will happen. And that's just a natural course. And I think that an irrigation industry that's being installed better has natural uplift for us anyway. We will sell more things if you do a better job of installing them, and the industry gets more respect, and then you guys can command higher salaries, and everything kind of has this natural uplift. So I hope that those 6 pillars help. It will probably evolve, and there'll be more. I don't know if there's much more. I've probably got a conclusion slide somewhere that I can't see because of my lack of ability to use PowerPoint. So what I'll do, if there's nothing else, we'll get Scott set up, and then we will announce before Scott speaks. Actually, I'll do it after Scott speaks because you'll lose them. There'll be people here just for the prizes, and then so Scott will talk now. If you guys want to take 10 or 15, we'll do as quick as we can changeover. Feel free to go to the toilet, have a smoke, whatever, and then we'll get Scott on stage, but no later than 15 minutes. Thank you.
Oh, claps.
All right, so for those that don't know who I am, Scott Muller. I represent a company by the name of HR Products, and I've been in the irrigation since 1987. So before some of you people may have been born. So in the last 28 years, I've worked for HR Products as a sales rep, and now under this role as training and product development, and also apparently Clint's customer or sales rep. So HR, we've got 5,000 lines in our product range, and then we represent more than 25 local and international distributors. Clint's asked me along today just to go through some troubleshooting products, and we'll go through that as we progress. But I've put up there 45 minutes. It's hard to see with these lights, but if people have got questions about anything that I'm going through, please raise your hand, get it out there in the open. You may not help, well, you'll definitely help yourself with an answer, but you may also help someone else in the room that's wants to ask the same question, and we can progress from there. So, troubleshooting irrigation systems. Easy to find problems are sprinklers, fittings and valves. Okay, Clint was just alluding there a minute ago with sprinklers. You've got failure to rotation, leaking riser seals and those type of problems. With the fittings, you've got leaks, improper gluing methods, valves, incorrect flow control stems, so on and so forth. They're easy to troubleshoot because you can see them. It's what you can't see that you need to be a little bit more switched on with. So when we're looking for issues where we actually need some diagnostics tools, we're actually looking at the controllers with a lack of AC or DC power, stations failing to activate, run zones, incorrect times, communication issues, and then you come down to the wire path. The controller, the solenoid valves and the sprinkler, you can easily see them in the ground. But the wire, you can't. So if you've had someone go through on a coring machine, someone else has been through and done any maintenance, they've nicked the cable, you can spend a month of Sundays trying to find it, and you never will. It's those times where you actually have to use some of the products that I've brought along. As I said with Clint earlier, this is nowhere near a sales pitch to you guys. It's just making you aware of what's out in the market, all right? So, next to the wire, cable degradation, unknown direction of cable. Cable doesn't necessarily always go into the pipe trench. So because you think that the pipeline goes from point A to point B, that may have been done because of for some reason, but when they came in and did the electrical, it may be in a foot, 2 feet off to the side. So with the correct tools, you can actually find out where the cables are. Not only where the cables are, but you can also find out what depth they're at, all right, just from using a simple tool. And then you've got things like the wire joiners, faulty connections. poorly made connections, improper use of electrical tape. Electrical tape, technically as far as I'm concerned, is an identifying tape. It has nothing to do with electrical. As soon as you put that onto a wire joint and that wire joint becomes wet, you might as well have not put any tape on it in the first place. Okay? So, and wire joints that are submerged in water, while I may have used the correct joint, maybe for some reason a previous person has, everyone used the DBR wires, they're about that long. They reuse them. They are a one-time use device. If you pull the cap out of it and you do any work with it, you don't go and get truck grease and refill it. You throw it away and do a complete new joint. Because if you use the wrong grease and you put it back in the valve box and that valve box fills up with water because of the irrigation or rainfall or whatever else the case may be, you're going to cause yourself issues. All right? So Armada is the brand that we've been bringing in for the last probably 15, 16 years. I was selling it when I was on the other side of the counter as a sales rep around the place. So I tend to sell what I would use myself. All right, I think, and the boys at Waterpro will attest, I don't go and flog them something just because I'm looking for sales. I know I will sell them because A, I'm not going to have hassles, and B, it's going to value add to their business and also to your business. So I'm just going to look at a couple of different methods that you can use. In some cases, you might have to use all three to get to find what your problem is. So for the controllers, we look for voltage. Controllers run off voltage. They send voltage down the line. That's what we're looking for. How do we measure it? If I passed a multimeter around the room, quite a few people will go, I've got a rough idea how to use it. I know red's positive and black's negative, but a multimeter's got so many dials on it and so many positions. What's AC? What's DC? What am I testing to check a diode? What am I testing for voltage, for current, for ohms? So we show you an easy way to do that. Once we've identified the controller and everything like that, we then look at the wire and the valve locations. Yes, it's easy enough to see the valve box, providing they haven't been buried. Otherwise, you're walking around the football oval with a rod, poking it in the ground, trying to find the top of the valve box. Now, that's good for aeration, but it's poor use of time. So we go through the process of saying, look, go out and get yourself, I think the boys at Waterpro actually hire out a cable locator before you go out and buy your own. You can go out and use something like this and actually find the cable path, take marking flags with you as well, so you can mark it, so you can see where it's going. You'll find the valves. You'll be able to identify where they are, and then that helps Matt and the team when they're coming through and doing their analysis of the system where things are. All right, and then we've got things like tone and probe. Luckily in Australia, if you have a look at a lot of the US videos and that, they believe they've got one colour cable, and that's red. They run red wire everywhere. If you cut a red wire or a bunch of red wires, it's very hard to identify as to which way they join up. Luckily in Australia we use multi-core cable, so it's a little bit easier, providing whoever did it, the extension to the job, kept the same colour coding. So there's some tools there as well for that. So the advanced multimeters. Okay, this is the Pro 30. Even this has had quite a few of the dial and the rotary positions removed. But they're incredibly valued for quickly determining if a circuit's electrical characteristics fall within the expected parameters of the coil. So you can use this here, and you can go up to, okay, full disclosure here, if you're not fully classed electricians or you don't have any idea when it comes to 240 volt, don't just go grabbing two probes and shoving it into a PowerPoint. All right? That's my disclosure. Get someone else to teach you how to do that first. Once you're competent in knowing which ones to actually put the probes in to find out if you've got 24 or 240 volts, then do it yourself. Don't just grab it and poke it in there. What you can do with this basic device is look for 24 volts out of the controller. All right, most of the controllers will take 240 in and then we'll change that from 240 down to 24 volt AC. Or you may even change that down to DC depending on what type of system you're actually running. But with this, you can actually put it in there to see if I've got 240 going to the controller. Okay, downstream side of the transformer, do I have 24 volts? Yes. Do I have 24 volts at the controller? Yes. I turn on station number 1, not operating out in the field. Have I got 24 volts coming out of the controller? Yes. Controller's good. Now I know that I've got a problem out in the field. So a multimeter is good for that. You can also do things, and I think it's here on a later slide, so you can check, there's the symbol that you use. You're looking for between 24 and 36 volts, and that's the position that you actually have the dial at. You can check what your solenoid coil condition is like. All right, so we're looking between 20 and 100 ohms resistance, and that's what that mega ohms. And see what the coil is like. It could be that the coil is completely destroyed through a lightning surge, which is something completely different again. It could be a poor wire joint, it's going to earth. If that number is high, then you've got an issue with the solenoid coil or the path going out. If you need to check batteries, okay, so there's the symbol for alternating current and there's the symbol for DC. You can check fuses. Yeah, controllers still have fuses. So even though I've got power going everywhere, there may be an internal fuse that you just actually have to check. So we put it on ohms, we turn the speaker on, and every time you touch the two wires together, they will beep. Yes, I've got a circuit, or yes, I've got a circuit. No, I don't. Very simple method to do. I asked Clint earlier about the level of knowledge in the room. I've put this one here, it's the Pro 400 for those councils that want to go to the next level. Basically what it does, it puts an electrical signal down the two wires and it will come back to you, right? It's what we call a time domain reflector, TDR, and it will come back and it will give you the cable path. So in this here, the total cable path is 180 feet. Cool. It doesn't tell you that that's in a straight line or it goes out and around. It just tells you it's 180 feet long. These spikes, and it does take some learning, but each one of these spikes, dips and gullies refers to something down here. So for example, at this point here where we've got a drop away, we would have a decoder. That looks like that. So if I move this line here, and it's movable on your screen, so back on here you can move the line that you see on the screen across, and it will tell me at, in this case, 99.8 feet, I have my decoder. That's great. I know it's 100 feet away, but which way does it actually go? I'll show you that in a minute. The top of the line, how many people here have got decoder systems in place? 2-wire decoder systems? Yep, okay. So the most critical tool, if you operate a decoder system, is a true clamp meter. Not just one you buy from Tandy or Dick Smith or whoever's still around, a true multimeter. Someone's nodding there. Saved you how much time? Correct. So what this actually does, sorry, I'll put it back down here so you can see it. What it will actually do is, everyone knows how a decoder system works. All right, you've got, there's your controller, and as you come out, there's your 2-wire cable path going off various areas, and each spur line here, you've got decoders around the place. I'll just do a couple more. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 decoders out in the field. Now, I know that each decoder, and every manufacturer is different, but I know that each decoder pulls in, let's, just for math's sake, we'll go 10 ohms. All right, follow the maths. If I grab that clamp meter and I put, remember there's 2 wire paths, so I test each wire. But if I put that around this wire here, that reading that I get on that device should be close enough to 80 ohms. Sorry, 80 milliamps, not ohms, milliamps. Milliamps. If I get a number there that's 456, then I know that I've got a problem out in the field. So the easiest way, and remember at this point I haven't even grabbed a spade out of the back of the ute yet. What you do is you do the half method. You find a halfway point, let's call it here. I will measure the voltage or the milliamp draw out this side, which is 2. At this wire path here, I should have 20 milliamps. If I have, everything on this downstream side of that is good to go. Leave it alone. Your problem's back this way. If I now check this wire path here, I've got 2 decoders out there. Once again, 20 milliamps. Good. So I know that that wire path and that wire path going out in those 2 directions are good. I can come down here now. So I've tested those 1, 2, 3, 4. And now I've added on 5, 6, 7. So now I've got 7 decoders. 7 by 10 is 70. So on this wire path here, I should have 70. On this one here, I'll have 30. So it's a bit like just working out the maths as to what you've got out in the field so you can actually see that back on this. And it's simply with this. You put it on milliamps, you open up the clamp, you put the wire through it, and it will give you the reading. You take it off, put it through the next wire, the readings, the numbers should be identical. All right? But what happens is when you get to a certain point here, you know, let's say our number was 400. Well, all of a sudden, to this point here, I know that I'm good. Once again, still haven't taken a spade out. Going out here, I've got 70, so I could have this single 1 decoder out here is reading 430 milliamps. We know it should be only 10, so I know my problem now is that single decoder. I can go to that decoder, take it out, inspect it, do what I need to do, reprogram it, put it back in, happy days, I move on. All right? So it may not always be a decoder. It could be every single one of these wire nuts that are in here. You test the 3 sides, do the maths as to, okay, I've got 1 decoder going out here, which is 10. I've got 7 going out there as 70. 70 plus 10 is 80. Measure this wire here. Does it equal 80? No, it doesn't. Could be the wire nut. The wire nut could be wet. The wire nut could be damaged. Or it's not even installed properly. It's got electrical tape around it. So by using simple tools like that, you did a system and we were actually able to troubleshoot it down to a specific piece of wire. All right? And at no point did we actually, well, you know me, I went out there and had a look other than getting covered in grease because of the wire nuts were in there. I never took a spade with me because I knew that that device was actually going to help me troubleshoot the system. So, definitely true RMS. It is a true multimeter as well, but it is the only one. If you talk to Hunter, Rainbird, Tyro, and all the major players that do decoder systems, they will always basically specify Amada cable locators. and diagnostics tool because they know it works. Once again, if you're not sure on how it works, you know, there's plenty of videos online. I'm based here in Adelaide and more than available to go out and help you troubleshoot something. But this is what we were saying before, the process of, okay, I'm using an old Hunter controller here, but we've got 3 valves. I know that each one hypothetically is 10. On that wire path, I should have 30. Check the other one, I should have 30 on that as well. If I've got another number, what I would do is shift this down to here. I don't have to do it on this cable here, I do it in the valve box. So I test each side of the decoder. The cable going in to make sure, in this case, on the downstream or the inlet side, I would have 20. On the downstream side of the wire nut, I should have 10. If it's not 10, chances are the fault's down here further. Do the what we call the half method. Go halfway back, and then it will narrow it down to basically a 20-metre section of pipe, 20-metre section of cable where your problem could be. So you've identified that you've got a fault in the cable. Cool. Where is it? It's in the ground, I can't see it, I don't know which way it travels. So this is where we come out and we actually do, well, we don't come out, we suggest you go down the path of a cable locator. So with a cable locator, what we're actually doing is inducing a frequency on the cable path and then back to the ground. So I wasn't here for Clint's presentation, but you know, voltage comes out and creates a circuit. It's the same thing with cable locators. We will do, in this case here, you can do either a hard connection between the device. You can use a clamp meter, which goes around the cable, so you don't actually have to do any disconnects. Or in this model here, this here has got a broadcast mode. You sit that over the top of the valve box and that will broadcast it down onto the cables in the ground, so you don't actually have to do any connections whatsoever. Obviously, if you're doing direct connection, it's going to be more powerful. When you're doing, as a tech tip, I get this one a lot of the time. If this was the cable path going out to the field, I'll do it under here. If this was the cable path going out to the field and I put the clamp meter around it like that, I'm only inducing my signal on that short piece of cable inside the clamp. So what I always say to people is, and you watch this, it won't allow me to do it, is if you've got a heap of cable in the valve box, put it through as much cable that you can, and now I've induced it onto 4 or 5 times what I had before. All right? So they're the 3 methods, the direct broadcast and also the clamp meter. So with a cable locator, we use it to identify the direction and the depth of the cable. Nowhere on this device or any other device does it say, when I'm standing over the piece of the cable, as to what the depth is. How do you think we actually figure out what the depth is using this wand? All right, so nowhere on here does it actually say the depth of what it is. Anyone used these before? Got these in their kit? Yes, no? Basically, when you've got that set up and you're transmitting, and I'll use this centre crack here as as my cable path. When you've got the circuit, so Perth have a real problem with it because their soil is sand and they can't get the field. So if possible, do it on a wet day or run your irrigation the night before, because now the circuit is being from the direct connection to an earth rod. So I'm getting that signal on that circuit. But as you walk along, you'll go along this and people have it set up on null or peak, and basically when you're over the top of the cable, it'll buzz. When you're off of it, it'll stop. And as you go through, you're just walking along like this, and you'll get to a point where you might lose the signal. So I normally go out and around like this. Nope, no signal out here. I come back here. I'm still getting a tone. shift it a couple of inches each way, and you go, okay, that's the end of my cable, or that could be my solenoid coil, because remember, the solenoid coil's got metal windings in it that makes it retract. That's a high reading that you'll see on this. So when you get to that, and we'll call it this crack, for example, here, this intersection, I need to know now how deep that is. So what you can do is, if you know that it goes in a straight line, you can go to here, turn it 90 degrees to the cable path, tip this 45 degrees, and as you move that out from the side, so now I'm virtually hitting it from a 45 degree angle. Once I get that noise again, I'll lift it up. I measure the distance between here and there, and that is now the depth of my cable. All right? Just equilateral triangle. So we had a case back in Victoria where we went out, did a cable location, yep, problem, okay, let's identify it as to where the fault was. And the contractors, okay, we'll get out the way and we'll start digging. I said, well, hang on, let's just take an extra 10 seconds here. Went out, dropped it down 45, brought it back across, went back to it. That was the wire. It was less than an inch under the ground. Now, he was going to hit that with a spade with the brute force of a 40-year-old man. All he would have done was cut the cable. So for that extra 10 seconds, you are going to save yourself a hell of a lot of work. That'll punch down, I think it's 2.4 metres. All right, so if you do this and you come out and you're back out here shooting at an angle, well, A, that gives you one of two choices. Either A, give the spade to the apprentice and say, keep digging while I go off and have a smoke and whatever else. Or B, you call up one of your other mates with the excavator to come in and start scratching around for you. All right? Just a little bit of common sense. As I said, using the clamp meter and a ground fault locator, which I'll explain to you afterwards. Some of the other tools that you will possibly need to take with you is that spade to dig up to find that shitty wire joint that was put in place. Wire joiners, side cutters, marker flags or line marking paint, so that as you're going along and marking this, you can put a flag in there. Yep, oh no, now we're off here. This is nothing worse than looking behind and trying to work out where your footprints went. And then I've put those two there, patience and training. You are not going to learn it in the first 5 minutes of picking up the equipment, especially if you use the TDR. This here, do a nice simple one for starters, progressively get more technical with it, and you'll be able to pick up all your faults out in the field or where things are in the field. Any wire nut or wire joiner, any solenoid coil, with a trained ear, you will actually pick the difference, because before you were just looking for a piece of cable. Now you've got a solenoid cable with a heap more wire in it, so you'll get a different reading here, and then it will go on. So the 900, as I said, we've got the direct connection, the inductive clamp, and the broadcast mode. It's a simple process. There's your grounding spike. You take the black wire into the black terminal, goes to this, and you put the red wire on the wire that you're actually going to look for. If you put it on the common wire, which is quite okay, you put it on the common wire, you are going to trace the whole system. But if you're looking for station number 2 that doesn't work, you put it on station number 2 wire when it's disconnected from the controller. And then that will trace the number 2 wire out in the field. All we're doing is inducing a frequency that this handpiece and this transmitter are both looking for. The GFL. A trained ear, as you're walking along this cable path, a small nick on the side of it, and it could be just where someone's got to use the knife and cut the cable off the spool to start with, is enough to take a system down. All right? With the GFL, or we call it the Zimmer frame, basically what it is, it's just once again, we induce a voltage or a signal onto the cable path, and then using this frame with our 2 metal prongs on the end with a little reader on the front of it, it will say, when you put it in there, the needle will point this way, and it'll go, your fault's down there. Because I've already done my cable location and marked it out with my flags, okay, down here a little bit, still that way, still that way. And eventually it'll start moving across until you're over the problem. If I go this way, it'll say it's back that way, it's back here. Now what you do is you turn the device, once again, 90 degrees, and you move it this way, that way, and it's to that point there. And you know straight away, if you dug down at that point, pulled out your cable locator, hit it from the side, you would dig down and you would find a knife cut in the side of the sheath that is causing you all the grief. You won't get that with a cable locator, because if that's where the nick was and you went like this, you just missed it by about 1.5 foot. With the Zimmer frame or the ground fault locator, it will give you piece by piece by piece as to which way the fault is. I know that there's various councils in amongst the room and contractors and stuff like that. In country Victoria, the councils are somewhat friendly. But rather than having one council go out and have all the gear, one council will buy this, another will buy that, and so on and so forth, and they just share it amongst themselves. It's a nice, easy way to share costs. So, as I say, the ground fault locator, very, very useful tool for nicks and that in the cable path. But once again, you've got to know where your cable path is. Multi-function testers, Pro 48K, it's a good little tool. As I said, if you've got a homeowner and they're kind of thinking that what you're telling them is a little bit of rubbish, this is a simple red light, green light scenario. All right? So when you've got it on here and you've got it in off and clock test, if I took these 2 clamps and I put it on the 24 volt terminal of the controller, it would light up and say 24 volt AC, green light. It's good, I've got 24 volts. Remember that before I said about the multimeter, getting it set in the right position? If you don't know how to use that, something like this is nice and easy that you can have in your kit. Then once you've done it, okay, so I've put it in clock test, I know that I've got 24 volts. I'll put it in the solenoid mode. And if I had these 2 wires separated and pre-prepared, solenoid coil I prepared earlier. So imagine this is the 2 wires going out to the field, and I'm clamped onto those 2 wires. I can see here quite easily that I've got an open circuit going to the field. If I connected it correctly, it would come up and saying that I found the solenoid coil, because you may have heard it click, and it's good. Now the good is that it's checking the resistance going out to the field. If it was bad, it would come up with short. That one simple tool going up to the wire that comes out of your controller onto the problem solenoid coil will tell you whether or not you've got 24 volts coming out of the unit, whether or not you've got an open circuit, a short circuit, or there's nothing wrong with the cable path going to that coil, you've got a hydraulic issue. Once again, one thing you haven't used so far is your spade. It's as simple as that. Of course, when you get to the valve box, and in a residential application, there could be 5 or 6 valves in the one valve box, and you don't know which one's which. You can leave this back at the controller, and on the side of it is a little lever. Okay, all that's doing is cycling power going to the coil. So you can go up to that valve box now and go, I know that that is the solenoid valve that is causing me the grief. Obviously, when you're doing this, make sure your mains water's off, otherwise your sprinklers are going like this the whole time and going to cause your water hammer and then blow something up. So make sure your water's off, but that's going to help you identify as to which coil is actually causing you the grief in the valve box from a residential side of things. All right, a very simple and easy to use tool. It does have a cool little add-on thing where you can actually, you know, I was saying before about in America where they all have the same colour wires, or you want to check which wires are what. You think there could have been a cable change somewhere along the way. You put this onto the failed valve or the valve wire you're chasing. You put it into send tone, and this is one thing that these won't do, is you can actually now go up. It's got a light because of the dirt and shit. You can go up, right, and you can touch it on the end of the wire. So I know, and it's got sensitivity on the side of it, so I can just dial it back a little bit. Too far. I touch it on another one. I touch it on another one. I touch it on another one. I know that that is the wire that this is connected to back at the controller. It may be blue back there, but it's purple here in the valve box. That's the wire that I've got to reconnect back up to station number 2. And you put that back in your pocket and you move on. You have someone at the controller, you say, okay, grab the next wire, red, okay, I'll try red. No, it's not red, it's green. I know that that's station number 3. Once again, simple little tools. How am I going for time, Clint? Okay. Well, there you go. Thank you. Is there questions? Is there something that, you know, I went through this pretty quick, trying to, I know what it's like, people are trying to knock off for the day and they've been sitting here all day. But has anyone had experience with cable locators or have got something similar? And yep.
Yeah, cable locators on our.
Yep. Look, we always recommend dial before you dig. All right. That's a given. But sometimes once those guys have been and you've got your marker flags and that there and you want a quick identification, you can grab something like that and just do it. As long as it's metallic, we talk about solenoid coils, you can do it on 240 volt AC as well. You can do it on data cable. We're looking for the signal and the circuit going through the whole system to allow us to pick it up. I picked on DLM before, but they had a system which was close by home, which was handy for them. And it was a case of I carry one of those 95s around in the back of my car so that when I go to sites I can troubleshoot them. And basically you had a hell of a shit show going on out there. Still do. Not through that fault. But you've got an easy way to go, and because that was a case that they went there and they didn't know where everything had been running before, drawing a bit of a mud map out and going up to a valve and going, okay, well, I see what my reading is here, but I know that I've only got 10 decoders down there. So I can tick this cable path from here down there to be good. Let's forget about that area. Let's go over here now. You go over there and start looking around. Now this needs more investigation, or I've got a higher reading, but I've only got 20 decoders, but I'm reading 600. Okay, well then I'll go halfway down again. Now it's good. Now it's bad. This piece of cable here is the fault. So I think in the end, at one point there, we replaced, well, there was a cable running up across the top of the ground, wasn't it? That was giving us nothing but grief. As soon as we disconnected that, everything was perfect. As soon as that cable got connected, everything turned to shit again. All right, so don't underestimate, like something like these. Yeah, hands up, they're not cheap. But the Pro 95, even if it was $500 and you're charging, what, $100 an hour, after 5 hours of troubleshooting, you're in front. And I've seen it where people have said, if you want me to go and find your valves, that's good, I can, even on the domestic side of things. But as soon as the lid of this box gets opened up, the price is, yeah, who did it? Cha-ching. The price just went up. But I'm going to do it in half the time of someone coming out here and scratching around with a spade and possibly hitting the cable and nicking it and actually causing a worse issue. All right, so just remember, as I say, the Armada brand is a well-known brand. Every product comes with QR codes on it. So if there's something that you're out in the field and you're trying to troubleshoot and shit's just not working, have a look at their website, have a look at the QR code, and you can visually put in there as to what the fault is, and it will show you a video as to how you actually solve it.
I think online, if you look at them online, they're actually the international ones. So
Yep.
right, so
Yep.
right. If you are buying it, just make sure you get it right.
Yeah. Some of these, I think this one has had it removed. No, it's still in here. So these new ones are coming out. This has got the AU plug on it as well, where you can actually now put because it's 12 volt DC it's running off of, you can plug it into your cigarette lighter in your car or your thumper battery or whatever like that and put rechargeable batteries in there and it will keep it charged for you. So you're not going through the D-cell batteries constantly. All right, but yeah, other than that, are there any other questions? No? All cool? Thank you.
Okay. Thank you, Scott. When Scott said at the start that he, I guess, effectively isn't necessarily here to sell you anything, I had to laugh because Scott was actually employed by the business he works for as a training and product manager. And then we had a sales rep that was looking after Waterpro leave and they gave us Scott in the interim until they found someone new.
How many years ago?
7. And when they rehired the role, I said, I don't care, we're keeping Scott, you can shut the account. And so Scott's a really important part of our business. He is a great support, but he doesn't need sales because he doesn't get managed on sales. And that's the beautiful thing. He's not in there trying to kind of shove things, I guess, in our shelves. I got you this to say thanks. I appreciate you taking this gig on short notice. No worries. I asked Scott to do this on Wednesday. I was trying to build out the training and I needed someone with some brains to kind of bring it home. I'm sorry I gave you the last hour, but I hope that helped. I didn't know a lot of that. We've sold these, but I'm not at the cold face of the business anymore, so I didn't know a lot of that. That's pretty cool. I don't even know if we hire them out. That's the first time I'd heard it. So
We do now.
we do? Okay, cool. Well, Scott gave us this one for free and we can hire it to you.